So, welcome to AI in a Day. I am Dr. Jerry Smith. I am AgileThought's Managing Director of Analytics and Data Sciences, which data sciences includes machine learning, AI. You're going to find all about that today. This is the second in a series of AI in a Day that is brought to you by Microsoft and AgileThought, designed around getting practical in this space. Now, I know you're probably saying, I've heard all that before and blah, blah, blah. And, pretty soon we start bailing into product announcements and, pitches for services and stuff like that. One of the promises I make you is that will not happen today. My goal in life is to share with you real practical knowledge that is designed to make us all more productive, with the hopes that I'm paying forward, and as a community, we share and we change the world. So one of the things that you're going to hear me talk a lot about today over the next couple hours is we are here to change the world and not observe it. And that's the theme of our AI in a Day. We want to get everybody in this spot of changing the world. And back here, I have a crystal ball, which you can't see, which my wife gave me years and years and years ago as a young data scientist, when she realized that the kind of work that all of us do in this space, and that is taking data, figuring out what's important, and then helping people understand how the world will change tomorrow. She says, you're the modern day digital equivalent of a crystal ball reader. And I took that and I ran with it. And more importantly today, I realized that in addition to foretelling the future, we also have to be in a position to change the future. And we're going to get into that as well. So welcome to AI in a Day, second in a series, kind of fun. And a couple little things here. You should have a couple things. It would be very helpful if one of you out in that land went over to a message board here and just typed in a message saying, I'm here. I'd love to see if that thing's working. Last time we did this, we did not have that. And it was just Arnie and I talking to each other, pretending to have a group of people out there in this world. So if anybody can do that, it says it's open. I'd love to see a 1 or 2 message saying I am here. And matter of fact, just to make it easier, this is where you will type. I'll just publish that so you can see what happens when I publish something, and then somewhere in this space, hopefully we'll be able to see something. And I see a hands up, I see a thumbs up on a couple things, but I don't see any new message. So don't know if it's working or not, but if you're in that space. So what are we doing today? You should see Arnie. Arnie's here. That's awesome. He's a moderator. Oh, wait. We actually have Kathy from Texas. I'm going to show them to publish. Thank you very much, Kathy from Texas. Or is it Katie? I think it's Katie, K-A-T-Y from Texas. Katie from Texas is there. So thank you very much, Katie, for letting me know that it's there. And by the way, I do love Texas. So what you should see here is, you should see AI in a Day. Sitting up here, you should see me in my office, dressed from the waist up in my professional suit here, and then from waist down, I'm in jeans and socks, just to fill in the piece here. And what we're doing today, let's see if I can actually manage to do this correctly, is you're going to see both these are your moderators today. This is the guy on the left is me. The guy on the right is me, and the guy on the left is Arnie Steingrism. Arnie, you will meet in a little bit here. He's an amazing guy. He's our principal data scientist here at AgileThought. He is truly amazing in the sense that his understanding of this space goes beyond what I think most people do. He's going to talk to you a lot today. We both are, but he more importantly is going to talk to you a lot about causality, talk a lot about machine learning in this space. All right, so what are we doing today, right? Here's our agenda. Our agenda is to first of all get you set up in the lab environment, right? So this is a hands-on workshop. Now, you don't have to do the hands-on. You can just tune in and tune out the workshop piece by which is watching if you want to, but we're giving you an option to actually get into, ooh, look at all that. Look at all the anonymous folks coming here. I'm here, it seems to be working, I'm here. Hello from Apex, North Carolina. Thank you, Caroline. And Siang, is that right? S-I-A-N-G, I'm here as well. Thank you all. Thank you all. I see Torres as well. So in this space, we're gonna get the lab set up. If you choose to do the lab, we have spaces available. Arnie's going to walk you through that process. It'll take just a little bit of time, and then we'll spin that up in the background. Then later on, you'll be able to come back and we'll deal it. While we're doing all that work, I am actually going to talk to you about artificial intelligence as a perspective, right? Two basic sections in here, and my intent is to provide you our point of view on this, which is designed to be business focused in nature, right? So we're not going to get into, you know, the 8 degrees of freedom when it comes to causality. We're not going to get into the future work that maybe causality is impacted by, you know, the quantum entanglement, right? I mean, which is, by the way, a possibility. We're not going to get into that. We're going to talk about it as if you were working in a business unit. And Arnie and I are going to take you through a couple things. So I'm going to walk through those sections. It's a little bit of material. I promise it's the only PowerPoints you're going to get today. My intent is that you're going to find a few of these slides in here that you're going to want to take with you and incorporate in your life as part of this process. Then we're going to do a walkthrough, right? So Arnie's actually going to start from scratch. We're going to take some data from UCI around the breast cancer data. We'll talk more about that. We're going to go from beginning, how we bring it in, how we process it, how we get it into a unified record, how we then do causality work. We're actually going to make some science today, I think. And then from there, we're going to go out and build a classifier in the Microsoft world from which we can then do some optimization, which we won't cover today. We're going to do that. That's all going to be done in 30 minutes, right? We're going to go from 0 to hero in 30 minutes. After that, you're going to then put your fingers on the keyboard, and we're going to take some data from students' education process, and we're going to see if we can discover and build classifiers, predictors of students' performance. And as we get into it, you'll see why that's important. So we're going to use some more UCI data as well. And then we're going to have the last piece. There's one more slide on this. We're just going to talk about optimization. We're going to talk, and that's a really super important piece to our world, but it's a hard piece to explore here in WebEx land, in that particular space. So that's our goal today, is to get through all that, probably 2.5 hours or so. That's what had happened on the last time. While this is the second event, and we're repeating some stuff, and we're not repeating everything. So if you attended on the first one, hopefully you'll get something new out of this one. You'll see some new work in there and some new advancements we've actually made and we're bringing to you. Our next event we'll talk about is well down the road. So with that said, I think I will move into turning this over to Arnie, and he's going to get us going on the lab setup. So again, if you have any questions here, I see you know, folks have dialed into the question side with a few folks that are anonymous. It's an interesting first name. I think I'll adopt that one as well. Again, folks from everywhere from Carolina to Texas, you name it, they're everywhere on planet Earth. If you have questions, type them in there. Now, before I do turn this over to Arnie, I've done this before. Some folks sometimes think this is an opportunity to see if they can get the presenters to jump through fiery hoops of death, right? I'm going to concede something right up front. I've been in this world for a long time, 61 going on 62 years old. My PhD's in computer science, specifically in artificial intelligence, and very specifically around evolutionary computing. I run nuclear reactors on submarines. I've flown jets off carriers, right? I've built stuff that people probably have never seen before. But I will confess that there are, most likely on this group, there are people far smarter on the subject than I am. I just happen to love this world passionately because I want to change it. So if your goal in life is to have me jump through the fiery hoop of death, just type in there, fiery hoop of death, and give me the question so I at least know where we're starting from. And I will do what I can to address it. If your goal is to stump the moderator in a question, I will guarantee you, I can come up with a list right now that will stump me in a heartbeat. On the other hand, if your goal is you're struggling to understand a concept, type it in there. Let me know, right? I'll take between Arnie and I will take a crack at it at the right time. And before the end of today, we will acknowledge the question, assuming of course there's not 8,000 of them, right? We'll acknowledge the question and I'll let you know whether or not I think there's an answer to it or whatever. And then if somebody wants to have me jump through the fiery hoop of death, that there's one in there that is particularly humorous that will get me hopping and jumping, I'll bring it up, man. I always love fun little, gotcha kind of moments in there. But again, the messaging is for you to say, what the heck, I don't quite understand this. Can you help us in there? It's not quite real time, but I think it's as best as we can do within this ecosystem. Okay. So with that said, you're going to find out from Arnie how to get to Bitly, how to register, how to activate your account, launch, details, getting your password, getting over to the portal, and then launching the studio, kicking off the cluster, and then uploading the lab files, which you should have received. And then with that, I'll turn it over to Arnie. And then after that, he's going to come back to me, and then we'll move on to the next thing. I'll leave this thing up right now for Arnie. Go ahead, Arnie.
All right. Thank you, Dr. Jerry. Great introduction.
And you know that you got to put your picture inside thing. Oh, look at me.
Switching it over.
Yeah, I know. You got to click the little thing on the side and then click your. There you go. Thank you. Back to you.
All right. So first things first. I put into the Q&A the link for the Bitly. So that's going to give you to a website where you can start registering for the lab. So let's just start there. You click on the Bitly link. You type in your registration information, and then once that's done, you can click and launch the lab. And so that's where we are in this area here. So we're not gonna use a virtual machine or any of these pre-configured labs. So we're gonna jump right away into the environment details. So this is kind of all the information that have been configured for you for the lab. So each one user that registers will get a unique username and password and all the resources necessary to do this lab. So to begin with, we will have to let's just start by copying the username. Click on that link, and then we will gonna jump over to Azure Portal. And if you're new to Azure Portal, don't get intimidated. We'll walk you through it. So this is kind of the center for all of Azure and their services. But so right now I'm in my personal environment. So we need to go and some of you might already not have a environment, so it will jump right away into signing up. But since I already have an environment, I need to sign in with our new username and password. So I'll bring in a new one, and I'll paste in our username. And then we need to go back to the lab and get our password. All right, so now we're in our lab environment. And what we need to do next is to click on all resources. And this is gonna set up, or this is gonna show us all the resources that have been configured for this lab. And we're not gonna dwell much on this. It just shows that we have some storage accounts, we have some other services, but the most important one we wanna use is this Azure Machine Learning. So it has this lab beaker class. So we're gonna click on that one. And then we'll hit launch the studio. So this is gonna go, this is kind of the environment where all the data science will be working in. We'll go ahead and confirm our username again. All right, so now that we got our studio up and running, so this is where the landing page or the dashboards at the home here. So we have in the authoring section, we have an option to do notebooks, AutoML, and Designer. So we'll be mostly working in the notebook section to do our causality analysis, and then we'll be jumping into the Designer to set up a machine learning to a prediction model. Then we need to begin to go to the compute section, and we can see on the compute cluster has already been configured for us. but this is going to be only for running the machine learning models to set them up. But what we need to run the notebooks, we need to set up a compute instance. So we're going to hit create.
Hey, Arnie, real quick, there was a question about using personal Yahoo email to log in.
Did it not accept? You should be, whenever you registered, yeah, it should be able to use a work email, any kind of work email. Is it not accepting the personal one?
So it should be, we should be able to use any email. When you say work, as long as it's a valid email, it gives
right.
Okay, so I'm going to ask our marketing team to sort of go off into backline there and see if there's something about a Yahoo email that is inhibiting the registration. So if you guys in the background can look at that, we'll continue on. I don't know if I'll have an answer to that one or not. So.
Gotcha. Yeah. Otherwise, we can shoot up.
But we'll continue on right now. Let's continue on. The team will look at it.
Yep. So the next step, is that we need to set up our compute cluster or the instance clusters. So instance clusters just to run our notebook. While we have a compute cluster is more meant to, we set up our kind of pipeline and then we kick it off on the cluster. So let's just pick the standard one here, DS3 version 2. You're welcome to pick any of those in there. So we're just gonna make up a silly name here. Hit create. So this is gonna take a minute or two. So while we're waiting on that one, there's a few extra things we could do. So let's jump over back to the notebooks. So click that here on the left. And let's start by importing some of our files. So you should have a files that got sent to you by email, and we're gonna go. So I'm gonna be uploading a few extra files because I'm gonna do the demo, and then I'll upload also your workshop files. So I'm gonna upload our dataset file, and you gotta say that you trust this material, upload it. And then we're gonna upload another folder. It's gonna be the figures. So that's just to have our figures that we wanna show in our lab, in the notebooks. And then we need to upload the files. So we have our files here. And then we also have 2 more files. So now we should have everything in here. So while we're waiting for the compute cluster to set up, I need to do one more thing, and we're gonna upload a data set. So a data set is important for machine learning, Azure machine learning. Well, not maybe, well, it is important. It's because it makes it really easy to share the data set between resources to go from Azure ML Designer to notebooks, any of those. So we're going to go ahead and upload 2 data sets. Or in your case, you're just going to be uploading 1. So we'll begin with the student. We're going to browse for that file. Hit next. So it's just parsing the data, getting it up there. Let's get a preview. So obviously it didn't capture that we have a header here, so we need to switch, turn that on so we can get the headers. So now that we have it, we can take a look at this all looks good. You can look at the schema. This should all be good. We'll just hit next and create. And then finally, let's go do, or in my case, I'll do one more.
Hey, Arnie, just one, pause 1 second. I just remembered, thanks to Caroline, she asked me a question, is this being recorded? And I forgot to mention that, yes, this session is being recorded for all those out there. So just to let you know it's being recorded, the link will be posted later on, but just to keep everybody in the loop, it is being recorded.
Yeah, thanks for that, Dr. Jerry. So, and then the final data file that I'm going to upload here is what we're going to demo. Get the headers back in here. This all looks good. Next, and create. And then want to check back on our compute cluster. It is running, so that's a good thing. So before I get it back to you, Dr. Jerry, I want to get everyone to jump to the notebooks, and we're going to kick off a installation of some extra packages. So go ahead and open the notebook. So we have 3 ways to view each notebook. We have them in the this internal Azure machine learning kind of notebook. Then we also have the other options to do the Jupyter notebook and then Jupyter Lab. So we're going to jump to the Jupyter Lab, only because that's my preferred way to do it. You guys can, yeah, use any of them you want. So at the first step here, we're going to have these 2 steps here. So go ahead and hit Control and yeah, just uncomment this, and then we'll do Shift and Enter, and we'll kick these off here. So while this is going, I think we can go ahead and take a small break from me, and then we'll take it back to you, Dr. Jerry.
There we go. Awesome. Let me go and get into this and this. We're back, send live. We should see me in this space. That's interesting. Let me just do this stop sharing real quick, because you're seeing the wrong side of the world. Oh, here we go. Here we go. This is the one we want. Now I got it. You'd think I'd never done this before. There we go, send live. All right, I think we're back here. We're gonna, thank you very much, Arnie. That should be set up. Arnie, I'm gonna ask you to camp on the new thread lines for people that are coming in into this world. And if anything pops up, let me know. Because if folks don't know this already, the way this works for us in terms of the Q&A is it goes into a new queue. Your things don't go up there automatically. We take a look at it, we click publish, and then we respond, right? In that space. Okay, so great. We got the ecosystem up. This is the sermon portion of the soup line where we actually get into a little bit of slides here, but hopefully the intent is that you will find some value in this, not necessarily these next slides, but it sets the context. Okay, so we all know that AI is an important thing, right? For 2022, we see it as almost a $4 trillion market. You hear those numbers a lot. 4 trillion seems like a lot of money these days. But what does it actually mean in terms of opportunities for us? Well, we see it breaking down roughly into mostly decision support and virtual agents, right? We're not going to talk at all today about the world of conversational AI, aka chatbots, but it is an important area, right? And I do want to put a placeholder for the GPT-3 community out there that is looking at using natural language generation, more natural language generation as as a means to which to engage people. And if you're in the healthcare industry, especially dealing with mental health issues, if you're out there in that industry, there's some really interesting new capabilities that come in this sort of virtual agents mode. And if you're interested in having us discuss virtual agents from an AI perspective, if you're in mental health, or if you're in banking and financial and you want to engage better communities out there, or if you're a call center and you're thinking about how do I keep my employees on, just put something in the comments over there. Say, hey, I'll sign up for something like that. And you know, won't be your traditional one. Again, it's going to be a Dr. Jerry version of all this, right? Then we get smart products, and that's really our heart in the world. My heart is in how do we make our capabilities more intelligent today. And then lastly, decision automation stuff. So it's an important world, right? And I think we know that, right? But then how does this world actually break up into various segments along the line? And I want to get to this feeding out here. And as we can see that, you know, in this world of deep neural networks, I often laugh, is like, you know, it's a standard tool for all of us today, right? I think one of the challenges we have in it being a standard capability, you're going to see where it fits in just a slide or two, is the fact that we don't think about it as a platform though, right? We're actually thinking as data scientists, I want to get into Python, code it up from scratch, or get into PyTorch, or getting into TensorFlow and doing this stuff from scratch. And there's so many wonderful platforms today within the Microsoft community and externally that allows us to do transfer learning and stuff like that. We'll get into that in a little bit. As we move forward, we see that a lot of analytics capability are integrating it, and then a lot of companies today are looking now to say, okay, now that I'm deploying some of these at the enterprise scale, how do I monitor them? And that is an open question. So as you journey down this path, as you sit there and say, we have these complex problems, we want to figure out what's causal, we'll get into the process. So we deploy these issues. The issue isn't anymore, can we do that? Yes, we can. One of the outstanding issues is how do we know these things are unbiased? Again, there's a short presentation that I can bring to which we talk about the Tay syndrome. For those, I love Microsoft dearly. They know I talk about this a lot. But the Tay syndrome has to do with chatbots, has to do with being able to monitor your advanced intelligent characteristics as they engage in real people out here on this space. You know, Tay, 2016, over a 2 or 3 day period, was one of the first really intelligent chatbots that went out there. And she ended up doing things within the community that got her removed from that community. If you're interested in us talking about that from a chatbot, we'll incorporate that in the virtual agent world. And it's a wonderful case study into both how things can go wrong, and more importantly, how you monitor those things to make sure that they work correctly. But we'll talk about that later if you want. A lot of data scientists' tasks are being automated. I don't know, is that a good thing or a bad thing? It is a thing, but more importantly, we're at this spot now where 30% of new revenue growth is for industry-specific tasks. That's where we are. That is the awesomeness of where we are. We're no longer focused on how do I do data grunging or imputation or all this wonderful stuff. We really have business people saying, how do I grow my revenue through solving real world problems? How do I change the world? By the way, if you don't change the world, you're not going to grow new revenue. Just let that ponder on that for a second. That's Deep Thoughts by Jerry Smith today. If you don't change the world, you can't grow new revenue. So if you're a business guy out there that's responsible for strategy, if you're running a vertical market, if you're in healthcare and you're saying, you know something here, you know, we want to do something as a payer to grow new customers. If your first thought isn't, I'm going to change the world, you're not growing new revenue. Period. Right? So if you're a business in the business growth sector, which includes margin, and you're not thinking to change the world, you got to rethink that strategy. We're all in this to change the world. So we're going to give you some tools for that day. And lastly, 1 in 5 workers will engage mostly in non-routine tasks or rely on AI to do their jobs. My wife is a classic on this. She often thinks technology is out to get her. And I mentioned to her that in her iPhone, there's half a dozen really significant neural networks that are in there supporting her. All the wonderful things she likes to see when she opens up photos and she sees something from the past, or she types in there, show me a picture of a cat or a dog. All those are wonderful tools that are now enabled in the background through these AI capabilities that most of us take for granted today. Certainly talking to our chat systems that sit on our desk. I won't mention their names because they'll pop in and start talking to me, but you know the ones I'm thinking about, to just the background stuff when it just comes to doing a better job at providing us content that socially connects us in this very COVID disconnected world, right? Okay, enough on that one. All right, here's an important thing, AI adoption, a little bit on, oh, there we go, catching up to me. A little bit on, if you don't do this, you will die, right? This is, you know, oh, by the way, you'll have access to these slides if you find them at all valuable, other than to print them out and burn in your fireplace. This is one of the slides that people use a lot in changing the community and saying, why now? Why do we do this now? And AI is unlike any other technology capability out there, right? As a cognitive psychologist, we understand something very important, the value of education. There isn't a parent on this call, on this webinar, that doesn't see why education is valuable. That's why we get our kids in the schools. That's why we pay attention to them. We know the sooner they get on board with learning and process incorporating, that will have an exponential impact on their life, right? This last year, delay in education will have an impact on our children. Education is fundamental. It's the same thing here. AI is about making better decisions. We're going to learn about that in a second. And when you are on board that process before your competitors, there is very little they can do to catch up to you. There's this thing called the Reed model. It deals with Sarnoff, it deals with Metcalfe, and it deals with Reed. Three very, very fundamental foundational scientists. Sarnoff actually brought out the fact that, you know, if you own a theater and you want to double your revenue in a movie theater, if any of us ever remember what a movie theater is anymore, that you had to double the number of seats, right, or increase the revenue. But doubling the number of seats allowed you to do it. Metcalfe came along. Metcalfe was the father of the Ethernet. He was the guy that allowed us to plug in, if you remember those days, plug in an Ethernet cable into the wall and connect with other people. And he said, you know, the value of a network is proportional to the number of people you can connect with. So for you mathematicians out there, it's n times n minus 1, right? I can connect to n minus 1 other people, so do the math. It's big O n squared, right? That's the most advanced math we're going to get today. So we went from n to n squared. Reed came along and said, whoa, wait a second. If you look at eBay, right, you find out that that same n group can form these groups. And they can form groups around firefighters or photography and sell and trade and join each other's group. And if you do that math, it's 2 to the n. So we went from the value of a theater was n, the value of a network of people connected on phones was n squared, and the value of eBay model was 2 to the n. So as n gets large, very, very valuable. AI is in that 2 to the n space. As we roll out new intelligence and we allow it to help us make better decisions, we see this extremely fast exponential growth in value. And when I apply that in a market that has a zero-sum game, that is, we are competing for $1 in product, either you can get it or I can get it, and when I apply it, I take it from you, it could be game over for a lot of businesses out there. That's why we pay attention to it today. Because if we don't pay attention to today, this may be the person who does do it. This may be the day before you find out that you're losing your products and services out there. Very, very important piece. All right, so moving on. This is one of really 2 slides that I would hope you'd find some value in. This is a simplified version of what we're beginning to see today emerge as what we call the cycle of life, right? And we're going to go with, this is the premise. We're actually going to cover steps 1, 2, and 3 today. We'll talk about steps 4, and then of course 5 and 6 are out in the real world. So what is this all about? Well, at the very bottom here, we kind of broken in your traditional value generation process in terms of data, getting access to data, engineering that data, doing some analytics around that. What do I have? Why do I have it? What's missing? Stuff like that. Data sciences, and data sciences is different when you think about it from a business perspective. It's not data science from a data science. It's not from Arnie, Jerry, or any of the folks that are out there like Caroline and John, you know, that are joining us today. Data science to us is really about looking at that data and building models, right? If we think about, if I were to ask you the question, what's the average IQ in the United States? I think we'd all say something about 115 points plus or minus 5 or 10 percentage points, right? That is data science. That's a model, right? We actually went out there, we collected 300x million folks. We looked at their IQs. We then realized it was a normal distribution because we looked at it. We then said, well, a normal distribution, this mean and mode are about the same, and here's what it is. And by the way, if you want about 95% of the people, it's just 2 standard deviations. Here's the range on that. We do. That's what we talk about, building a model, doing real data science on data. We get to a model. And why is that important? Because right after that, somebody's going to ask a question. Gee, how's that going to change over time and space, right? If I think about our IQ next year, what's that look like? So machine learning to us is about prediction and forecasting, right? Forecasting a linear time series extension of a model. We all know, we all done it. Who in here hasn't invested or knows something about stocks? You can look at a stock chart and go, ooh, that's going up, Bitcoin. Ooh, that's going sideways, Bank of America. Ooh, that's going down. Pick any number of other companies out there. We have, as human beings, it's in our DNA, a pretty natural capability to project things in the time. It's a survival thing that we used to do, right? We'd see the fact that I think our vegetables and fruits are going to go away. We got to move, right? It's DNA. It's 100,000 years of evolution. We also have it in terms of space and time, left coast, right coast. What's the IQ difference in left coast, right coast? Can we predict that based on characteristics? So we spend a lot of time in the machine learning space looking at predicting our changes into our models as a function of something else. We're going to do that today. And lastly, artificial intelligence to us deals with the most important characteristic that human beings bring to a company, and that is their decision making, right? They don't hire us because we wear beautiful blue shirts or have a wonderful background in our home office. They hire us to make better decisions, right? To advance the company's goal to service people and to do it in a way that allows us all to float our financial boat together, right? Decision making. So artificial intelligence in our world is about helping people prescriptively achieve that through things that we're going to talk about later on, optimization, right? So in this world, there's six steps, right? We grab data real quick. I think I'm pretty much on time, I think, although my team often knows that I'm never on time, but it's who I am.
We're doing good.
Okay, good. This is often, I get excited about this stuff, right? So I apologize ahead of time if my passion and excitement takes me off in different directions. But like I said, I'm not a PowerPoint guy. I love talking about this stuff and getting other people excited. So one of the first things I ask almost everybody I meet in this space is, what's data? Right? I mean, there's between Caroline and John and Suman and all those other folks. I mean, you really super smart people out there, right? You guys, Chris has been around this for some time. So what is data? And, we think about it, we often say things like it's ones and zeros, it's a hexadecimal thing, it's a bit in a system, that sort of stuff. And I respond that humans really about the debris of human activity. It's because of us, not in spite of us, right? It doesn't spontaneously generate itself in some sort of database somewhere, right? All data is fundamentally the result of some human being doing something, which is then picked up by a set of applications, which is then persisted in a data store, right? So if you think about that simple model, that should really cause you to pause for a moment and go, wait a second, that's interesting. Where's he going with this? And where I'm going with this is that when we talk about changing the world, when we talk about growing our company, we have to change the world. What are we really talking about? Well, we're really talking about figuring out in that data that happened when I went and checked out of a shopping area and I have a point of sale solution, or I went to a website to look up how do I transfer my funds from one bank to another. Oh boy, if that is an indicator that you're going to lose a customer, what is? Or if I was on a call center call and I was logging some text in there that and as a result of the customer yelling and screaming at me that I'm a messed up idiot and I'm not listening to them, right? All those interactions, right? That data, we have to ask a question. What of all that data from 0 to 100% of all the stuff in your system is causal to our business concern? And what do we mean by that, right? We mean, and I'm going to talk about that on the next step, but it's causal. Why do we do that? Because once I know this causes that, not this is related to that, right? I look outside, I can predict tomorrow's weather, but I can't change it unless, of course, I know how to do cloud seeding, right? Once I know a causal relationship, that is, I change this information and the output changes, what can I do? Based on that fundamental belief that data is the debris of human activities. What can I do, John? What can I do, Carol? What can I do with that? Well, we go back to the application that generated that data, right? We go grab those folks and we say, hey, this data is important to us now, right? We just looked at chronic kidney disease and we found out that these lab results, this particular calculus in my body, chemistry in my body, is important to stage 1 diabetes that nobody realized before. We go back to the application that generated, and what do? We then ask the question, what human beings interacted with it and how do we get it? And why do we do that? So we change their behavior. If we can change the human behavior, the application will pick up new behaviors from that, which will then persist in the new data that persist in the changed business model. We change the world through that. So one of the things that we often talk about, sidebar, which we won't get into today, just put it as a placeholder, is almost every business development team in the world, if not in the United States, if not the world, is missing two important classes of people on their teams. What do you think they are, based on that last conversation? How do you change people? That's the question. And when you look around, who do you see doing? Well, you see sales and marketing, right? That's their fundamental job, right, to change it. But sales and marketing is also missing a couple of, they're missing psychologists, people that look inside your head, and they say, here's how we get you to change your belief system, and therefore your body follows. And we're missing sociologists, right? People, they study how groups of people working together. So one of the little things that we would talk about in the world of virtual agents is psychology and sociology as a means to change group behavior through conversation. That's a little placeholder for the future. If you're interested in that, put it in the remarks, and we'll add it to the content out there. But okay, that's step one. So now we know that data is the debris of human activity. It's more important to us than anything else out there. What do? Well, we have to go through causality, and that's what we're going to talk about today, right? We're going to actually do that. You're going to do that. There's different ways, and causality is fundamentally, it's a Judea Pearl kind of concept. We'll put in the notes here. When I stop talking later on, I'll get some stuff in there in Judea Pearl and what he does. It's fundamentally the book of why philosophy, right? So if you go to Amazon, look up the book of why, you'll see it. Everybody on this call, I guarantee if you read this book, you're going to walk away going, I didn't know. That is so empowering. I now have a new way to look at the world. We're going to actually get into using and creating, or using causal next to create a causal model so that we can see the actual part of the world that we can change, right? Since the data is causal, if I change the data through the means we just talked about, I'll change the outcome. So that's important. So what do we do with that? Great, Dr. Jerry. I have a causal model. That and $1.25, I'm still a $0.50 short from buying a cup of coffee at Starbucks. So what do I do with it? Well, what we do with it is we go up and build a predictor now, right? So, and what do we call that predictor that couples causal input data with a prediction about something in the future? We call that a digital surrogate, right? That's a very special predictor model. It just isn't predicting the weather. It's saying, here's how we change the weather. My favorite example of this is the salmon industry example in Europe. 26 salmon farms-ish over there. All those salmon farms back in the day would produce salmon at a different rate, right? They produce some salmon. Salmon fatness is important for the omega characteristics of it, right? So you want to get it fat as quickly as possible with the least amount of food, right? Least amount of effort to do that. Almost any business model is based on that. So what were they interested in? They're interested in unifying this process across there. So they collected a whole bunch of data, everything from what kind of food, what kind of nutrients, what kind of salmon, what was the water temperature, what was the salinity, what was the phase of the moon. Did not know the phase of the moon has an important impact on the fatness of salmon, right? Has to do with the salmon looking up and feeding at night so that you can actually increase. It's a lot like chickens, right? You put lights around chickens and they eat more and they produce more eggs. So in there, they collected all this data, they did the causality stuff, and then you take a look at it and then you do a predictor. So now you have a digital surrogate of a salmon. And the salmon says, I will tell you, output predictor, how fat I am, how quickly I got it, and what the cost was if you give me those inputs, right? And so you change those inputs and lo and behold, I get fat quick, least amount of cost over a short amount of time. It's a digital surrogate that we then move into stage 4 on, which is the optimized prescription. Now that I have a digital surrogate, what do I do with it? And your brain should already be clicking here, right? Your brain should be saying something like, oh man, if I can just find the input values that maximize my business benefit, I'm golden, right? So we use things like Monte Carlo. We use things like genetic algorithm, particle swarm optimization. We'll talk about these things later on to search that space across the entire spectral input content area to find the one combination or group of combinations that maximize our business benefit. Fattest salmon, least amount of time, least amount of interest. By the way, if you're going, salmon has nothing to do with me, replace salmon with product development, software development. What inputs will produce my software in the shortest amount of time with the least amount of energy and the highest quality, right? What inputs will allow me to acquire more customers in the shortest amount of time with the least amount of sales and marketing input, right? It's the same thing. And then from there, now that we have that, what do? We walk to sales and marketing. We say, hey, team, here are the things you need to do. We study those things from a human perspective. We put programs in place. We deploy it into the field. And then we sit back and wait. What do we wait for? We wait for people's behaviors to change so that what? That our applications pick up those behaviors, they persist new data, wash, rinse, and repeat. This is how you fundamentally bend your business curve, right? You will change the world by doing this, right? By the process and closing that loop out, right, in that particular space. I hope this diagram, this concept, becomes an important part of your thinking when you actually are sitting down to do causal or predictive or prescriptive work out there. Now, in this space, the layers below it are things like simulation, metadata, all sorts of other conversation that are layered underneath this, but that adds more color. If you don't get the major story to begin with, then you won't understand. Anyways, so moving on here, as soon as I can click on the right screen, moving on, ta-da. Let's talk a little bit about the data science world, and then we'll get into actually a demonstration of this. We are 9:50, good. All right, so this is the second slide I hope you take away with you today, right? A lot of us in the data science, machine learning, AI world often asked the question, well, what do I need to do, right? As a data scientist, well, you know, I need to grab your data, I need to do some grunging out of it, do some impugning, you know, clean up the missing values, get rid of them, blah, 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 blah. And we rattle that stuff off, you know, and then the poor business person on the other side is like looking at us like we have a third eye in the middle of our forehead, right? And they're like, oh my goodness, I don't understand anything that they're saying, right? Back in the day, we recognized that, right? And one of my team members also brought up the fact that we were failing quite a bit as data scientists. We weren't failing because we did the wrong thing, right? It wasn't like Arnie stood up to the plate and said, you know what? I'm going to apply this deep neural network model on this imaging system, and it turned out to be a time series stuff, and Arnie didn't know the difference between a convolutional recurrent. That never happens. What does happen, though, is a lot like in aviation as a pilot, is you forget to do something and it kills you. You forget to take the remove before flight tags off of your pedostatic system, and your altitude indicator is wrong, and you fly into a mountain in the middle of the night because you thought you were at one altitude and not another, right? You forgot to check the fact that you had put a C-clamp into somebody's bow before you sewed them up, and they got septic shock and they died from that. These aren't things that we did wrong, we just forgot. And so we actually undertook a study of all the projects we had done in this AI and data science machine learning space from a standpoint of why did they fail? Why didn't they meet the customer expectation? Why didn't they get the right, generate the right value? Why did it take longer than what it did? And we found out that in that process, we discovered there were a lot of capabilities that were interconnected that we forgot to do. So we put together this, and this has evolved. This evolves every year into a new version. We add new capabilities. And so on the very far left-hand side, from your perspective, you're going to see the world of data, then information, knowledge, intelligence, right? Information is the study of data. Knowledge is reflecting on information, right? And intelligence is wisdom, right? It comes with it allows us to make better decisions. So underneath all these, you'll see blocks that are color-coded. I'll talk about that. But those blocks are fundamental characteristics. We start with the premise that our data world either as an enterprise, we actually understand something about our customers or patients. It's an IT world where this is all the log files that result in the interactions. And then there's all the external world, right? The open source. Here's a second conversation we can have in a different webinar, which is all around the use of open source information today to do better job at AI, right? I do come from an intelligence world. It's very powerful. Turns out that 96% or so of all your decisions are predicated on data you don't have in your company. Open source information, whether you're using FactSet or you're mining Facebook or you're looking at Twitter, or you're actually out there looking at Google's images to one of the major lingerie companies looking at Google images to figure out what new trends are happening in Japan with the young women that might affect their product line here in the United States days, weeks, months down the road. All that information is stuff you don't have in your enterprise or IT. It is 96% of what you need to make really great decisions. So the translation is most companies today are making bad decisions, incomplete decisions, because they don't have access to it. I would argue that all of us on this call need to understand that, how to get it, how to mine it, how to do this process, and what you can get from it. So if you're interested, put it in the link and we'll know. So what do? We take that information and then we do things with it. We do things like text harvesting with it. We do things like causal analysis, right, which we're going to do today. We then do some descriptive stuff, and we go in and we take a look at some event analysis, and we do clustering analysis and traditional data sciencey kind of things. And then we go and do some decision tree work, machine learning stuff, and then we actually pop it into some sort of AI engine or whatever we do in Insight, right? So these are interconnected blocks. And then more importantly, they're also from left to right, it's like connecting the dots. We also have the kind of person, the level of knowledge a person needs to have. Person who is doing text harvesting doesn't need to have as much knowledge as a person who's doing causal analysis, or somebody who's doing neural networks, or somebody who's doing intelligent evolutionary computing. So we color code these as a function of levels, right? 4 fundamental levels. MVP is not the most valuable person. It's a sad carryover. I apologize. I'll tell you what it is. It's the minimum value person, right? It's a person, it's an entry level. I should probably change that to entry level, but it always has been MVP. The last thing we've coded is who does this work? A data engineer does harvesting, right? A data scientist does causality, a visualization expert stuff. So we have all that. And then lastly, on the very far right-hand side, you have the ecosystems we traditionally use here. And so what you see here today is what we're going to do. You see the pathway. We're going to take some open source information from UCI. We're going to harvest it with the tech stuff. We're going to do some causality work in it. We're going to then do some descriptive stuff and some classification algorithms. We're going to create a decision tree, and we're going to get some insights out of it. We're going to do this with a very senior level person in data science and data engineering. We're going to use Python, causality, and Microsoft ecosystem to do this work. Now, with taking a big, deep breath, this is what we do when we sit in front of a customer. We actually walk through this process, and now they're able to look at it. More and equally important, we ask ourselves, did we miss anything? Could I have done a better job with maybe some genetic work in here? Let me think. That's an optimization thing. Oh, we're not doing optimization today. Don't worry about it, right? What about insights visualization? Probably need that in a real work, but not today. So I'm not going to put that on. Here's my point. This becomes a contract between you, John, Caroline, etc., Chris, and the business people in terms of what you're going to do and why you're going to do it. And using linguistic processing, a special type of way human beings learn, speaking something, running out, going back into your ear, into your natural language processor, right? We tell our kids the best way to know if something is written correctly is to say it out loud. That's that process. When we say these things, our brain subconsciously picks up, doesn't feel right. Missing something. Don't know what it is. Let me look, right? This is very important. I hope you find as much value in this as I find and my team finds and other customers of ours found. All right, moving on, and then we'll get into a demonstration of all this, is machine learning on the Azure environment. Azure is one of the few ecosystems that as a data scientist, I absolutely value, right? This is not me not putting a product plug for them. This is just me having used their environment. I do not like to think as a data scientist, I don't like to think about the things that I'm doing, the ecosystems I'm working in. I want to get on with insights. This is one of the few places that I can do it, and you're going to see this, right? So again, the orange little dots here are the things we're going to use. We're going to use tools that are familiar to us. We're going to have some popular frameworks when it comes to Jupyter Labs, and Scikit learning environment. We're going to work within an environment, and we're going to get some infrastructure with CPUs. We're not going to use GPUs or graphical processing units today. We're equally going to go through this space, right? So these are all the things we're touching on today. By the way, you won't see this in the background. We're just getting on with our work, right? We're going to work in the notebooks. We're going to do the data sets. We're going to do some training criteria, very traditional stuff, 80-20 split, that sort of thing. We're going to do some compute within clusters, and it's all going to be based on CPU. All that's in the background. With that said, we can just move on now and get on with our life and doing some of this stuff without having to worry about it. A partner like ours with Microsoft, they actually get on with that. And that's what makes their world so special to a data scientist, machine learning, AI guy, right? Is that we don't worry about that space anymore in that particular worldly space. And lastly, one of the things that I'm always fascinated with is taking all this text stuff and making something fun and graphical out of it. So we're going to get a chance to see with the designer area in the machine learning side of it, how we actually graphically compose all this stuff. And again, I am not a Python guy. I'm an R guy. I'm not a Python guy, but I do recognize that the limitations that textual insights development has on the productivity of a person. So anytime I get a chance to jump in a graphical environment like Amazon's Azure ML space, it just really ramps up my productivity, and also ramps up my ability to tell stories with our customers, because they don't understand Python. They don't know what that code means. They don't understand R, but they can look at a block and say, oh, this is going to that, and you're going to see that today. Okay, so with that said, we covered the lab stuff, right? Getting that set up. We covered a little bit about our philosophy around AI. And the one slide I want you to take away is the cycle of life, the 6 steps. If you do that, I guarantee your life is going to change. If you just think about life that way, your life's going to change. We got into data science, specifically the capabilities model that went from left to right in that particular space, and why that's important. And we cover the ecosystem, all right? So I'm going to take a big, deep breath here. And now we're going to go on with a walkthrough. And so we'll transition change. We're going to grab, wait just a second. Nothing like a cup of coffee. Now that's something you and I miss by us not being in the same room, is just the nuances and the pleasures that we get in just taking that little breath and having our coffee, right? So now we're going to do a walkthrough. What are we going to do? Well, we may make science today. We may make some news in here. When Arnie and I did the walkthrough over the last couple of days, I looked at the results that we had and I went, okay, that was different, right? As we started to dig in and adding some more stuff, and I posted a little short conversation on LinkedIn with a new graphic. This came from our last session that we did. So once we've done with this one, I'll post the new graphic. So what are we going to do today? Well, as you can probably tell, I'm really big in the health. In a lot of my examples come from healthcare and life sciences area. And whether or not that's your domain or not, I think we all have been impacted to some degree or another with this thing called COVID, right? I certainly have had it, and it was a life-changing experience. But I think we're all aware of the importance that health has in just our everyday life, right? So for me personally, though, I love the space because, again, I believe that we can change the world. And what better place to change the world than helping people live a happier, healthier existence in life, right? And that is a very, very complex space. I was chatting with a guy the other day, Chris, not the Chris, I don't think it's not the Chris that's on with us today, but Chris, who's a CIO of a major food company, in the food company industry, and talking about food as science and the precision nature of that today, and how food impacts the nutraceutical characteristics of the body, and how that then impacts the health, and how that then impacts the insurance world, right? Through the things they cover and don't cover, and how that impacts your relationship with your doctor, and how that impacts the kind of labs that you get, and how that impacts the world of pharmacy, which is trying to overcome the body's natural tendency to respond to food in one way or the other. So we mask it with, or we we enhance it with a pharmaceutical, and then the folks in the nutraceutical industries, the Twin Labs of the world, they're out there saying, hey, life through better nutraceuticals, here are the vitamins and stuff you need. And all that is impacted by hypertension and stress about our relationships, about our job, and about the world in general. It is a big Mesopotamia ecosystem, which deserves a lot of attention. So whether you're in the food industry or the transportation industry, or you're in any of these others, you are in the health industry at the end of the day, right? So what are we going to do today? Well, we went out to UCI. For those who don't know, go to your Google world, type in UCI, Uniform Charlie India, and then put a space data sets after that, and you'll get to the site. I'm often amused at how many data scientists complain that they don't have enough data. You know, marketing people, oh, we are product people, we don't have enough data to do anything. And I just say the BS word. I go, you know, I usually hang up the conversation mentally after that because they just haven't done the job. You go to UCI, I go there every week and I see new data sets that are in. I ask myself, how can I learn something from this data set that will be applied? Well, one of those things we did was the breast cancer. Now, this goes back to 1995. So it's a study of five, don't quote me on this, you'll see it in there. 500, oh, here it is. It's actually in here. 595, 565, I can't see it. I'm squinting my eyes. People that looked at the, what's called a fine needle aspirated analysis of breast cancer, right? So they took a biopsy of this material, they brought it under a scope, and then they started to measure it. And this is 500, almost 600 results of that. And the issue was, is there anything we can learn back in the day from this? Well, it turns out, yeah, right? I mean, we know this. We're able to look at this today, plug it into a classification algorithm and say, voila, you know, this is malignant or benign. No new news there. But the real question that we were asking is, in all of the variables, is there any that's more causal to the diagnosis of breast cancer than others? All are part of an average analysis, but not all are causal. And that is that by looking at a characteristic of this, characteristics of this analysis, one can then make either a better or worse decision. And then equally importantly, if we extend this, the question too that is then posed to pharmacists and nutraceuticalists is, how does your stuff impact those values? Right? And if we can figure, and then now you're drawing an unnatural connection between their stuff and these characteristics. And then what do we know? This thing changes this characteristic in a positive way. The chances of it being cancerous are small. We may actually influence. So that's the way we sort of think through causality. So with that said, we're going to get into this space with Arnie. Arnie's going to do, it's going to be a quick 30-minute walkthrough. So you see the whole thing. And then after that, we're going to pop in and we're going to actually do a different study with you on causality and start, and your hands will be going. So with that said, I'm going to turn it back over to Arnie, and Arnie's going to walk us through the process, and we'll get through it, and then we'll move on. Arnie, over to you.
Thank you, Dr. Jerry.
Oh, look at that. I'm still in the picture. Didn't realize I was giving this presentation. Oh, yeah. That's a hint to Arnie. There you go.
All right. So back into the Jupyter Lab. So last where we ended here was that we were installing some external libraries. So with many libraries, they require the kernel to be restarted. So let's go ahead and do that. So go to the kernel here, hit restart kernel, clear all outputs, and restart. Now we start over and we can comment.
And by the way, this is Arnie going through the process. You're going to do the same thing when we get to your exercise. This is just showing you how we're doing it.
Yep. And I forgot to mention, put it in the notes that, yeah, you didn't have the demo notebook, but you had a part A and part B. And in part A is where you could install the external libraries.
And by the way, anybody out there that's interested in this notebook, just post it in the notes over here. And if enough of you, or if one or more of you is interested, we'll pop it out there as well. And you can do this on your own later on.
Yep, absolutely. So yeah, we did some initial setup by installing some external libraries. Azure also has many libraries by default, like pandas and others, and quite a few visualization libraries. So, but those are two kind of specific ones. We will use CausalNext for causality analysis, and then PyCharts for kind of greater visualization capabilities. So that's why we needed those as extra. Once they are installed, they will reside on your compute cluster as long as it is up and running. So again, if this goes down, it's not running, then you will lose those packages and you have to reinstall them. But as long as this is running, you will be able to keep those packages still installed, and you don't have to reinstall them. But so now they reside on the compute cluster, and we have access to them. Let's go ahead and import some of the libraries. So now we just finished importing all those libraries. Let's go ahead and get some few configurations. So this is just a Python or pandas, which is the kind of like the data frame, a library for Python. And a lot of times it goes in by default to, I believe it's 10 or 20 columns, the width, but we want to increase to 60 so we can see them without getting truncated. So let's go ahead and do those. We're going to initialize the JavaScript or load the JavaScript that we use for eCharts. And then we need to initialize or declare a data frame that we'll use for our data. So I included some widgets in here. So let's go ahead and run that. So and this is gonna have a, if you want to, you could switch between libraries. But so here's the library, or here's the data that we're gonna look at. So we have some issues with our notebook environment in Azure, but don't be alarmed. We can just get around this by typing in data.df, which is our data frame, and we get this slider here. So again, our widgets is for some reason hindering us from getting the horizontal slider. So we can't see the rest of the data, but we can just do it manually here. So here you can see the data set. Like Dr. Jerry said, this is a breast cancer data set where you have the data on, where we have this target column here, diagnosis, and it's to determine if, from the biopsy, if the tumor is benign or malignant. So if it's tumorous or non-tumorous. Then from the biopsy, they collect a lot of information on sizes of the tumors.
Right, for those that are interested, if you go and search on finite, if we're not all medical experts, I'm certainly not, but if you search on FNA, you'll find some really interesting definitions for all these things and what it means, right? So if you want to do this, I think Suman's going to, he asked for the notebook, we'll pass that over, and if he looks into the space, he'll be able to figure out. Again, this is just, this is open source information.
Yep. Thanks, Dr. Jerry. And then, so yeah, you can kind of scroll through and see we have a lot of features.
That was a thanks, Dr. Jerry, for interrupting my train of thought. Kind of thing. Anyways,
no. I prefer having an interactive session here. So now that we've gone through our data set, we got it up and loaded into a data frame. So by the way, in the background here, we just went through pulling the data set from our folder here in the data sets, and then we get it into a pandas data frame, and that's why we're reviewing it here. So the next step we need for the causality tool is that we need to pre-process our data. So again, well, I'm saying it for the first time now, so not again. The causality analysis will mainly break into two parts. We have a modeling the structure is the first part, and then the second part is the applying conditional probability model onto the structure. We're mostly going to focus on the structural part and try to explain that. And then we'll briefly go into building the conditional probability onto that model, onto that structural model. So for that structural model to run, we need to turn all the features and all the columns into a numerical values. So we need to turn the diagnosis column into numerics. So we need to encode it before we can process it. So that's what we're going to do here. But before we can do that, I need to drop out a column here, the ID column. So
and by the way, that's an interesting step that we'll talk in the next section when you actually do the work is making sure that in this particular case, it's obvious that ID has nothing to do causally with anything. But when we talk about in the next one, there are other features that sometimes people will drop out. We'll talk about why. So we have to be very careful in making sure that we don't drop out things that could lead us to a better understanding of the relationship between the thing that we want to change and the things that we have control over ahead of time. But ID is a classic one that we always drop off. But anyways, we're moving on to data processing now.
Yep. Yeah, so we'll talk more about the columns, which one we should drop and why when we get to your part. But for this breast cancer data set, there's only one that in question here is the ID that we need to drop. So we take that out, and then now this is where we run through our transformation and pre-process the data. So now that we've processed the data, we've converted, we dropped the ID column, and then we've also taken out or encoded our diagnosis column here. So again, 1 for M and or malignant, and then 0 for benign. The next step we need to do is to kind of have ready for us a data frame and a series. We do this to split off the features and the target, but when we go to your demonstration, it won't be quite as exactly the same. It will be a little bit different because you don't have to split it up into the target and the features, but we'll get back on and give you more detail on that later. So let me go ahead and show you, run this for a second. I need to specify also the target column. So we're going to specify the diagnosis being the target. And then we have our structural model here that we're going to apply. So this is a nonlinear model we're going to apply, and it will use, hold on here. All right, we're going to run this. We're going to fit the model.
And then when we get in the next section, we're going to talk about a little bit about the differences between a classifier, right? Binary classifier like this, malignant, non-malignant, and a regression, right? Where we have linear value, where we have numerical values in a range, right? So it's just something to think about. We'll talk about that more after we get out of the demo.
Yep. So again, the classifier being, we're just working on either a binary classifier or multi-class, but for this, we're going to do this is a binary 0 and 1, and then a regression works on continuous variable, meaning a range of values. So right now this is running and trying to fit the model. And we'll have to give it a minute here. It will probably run faster on your laptop than in the cluster. We didn't specify a really high-end compute. So what we're doing is we're trying to fit the structural model to our data set. And then I have here set up using pie chart. So this is going to be our visualization tool. So I just have some configurations here is that I take the structure from the results. So it's going to compute the structure, and then from there it has nodes and edges. So it's going to have some nodes that represent our features, and then it's going to have edges or a line that is going to connect with an arrow to other nodes that is going to explain to us our causal relationship.
Right, and therein lies one of the first benefits when we get into this with this output is going from the textual world of probabilistic curves, right, and values into the world of visually connecting. And this is, again, going back to the book of why, that, you know, understanding that A causes B or X causes Y, and how Z as an influencer or co-founder can influence both X and Y, right? When I say that, totally over the heads of probably most people, they don't see it. But when I say think of X and an arrow going to Y, and then Z and arrow going to X, and Z and arrow going to Y, you can begin to see a triangle, and then we can have conversations about that. And that's what we're going to see here. Is now we get into a visual world. So with your customers, with your business partners, with your patients, we can actually sit down and say, you know what, I've got a cumulative distribution function of 0.46 between you. It's, who cares? It's just going to go over their head. But when you start to see the causal networks starting to mature and see things that are causally related, confounders, things that are actually influencing the variable you thought, and we're going to see this in the education one. We'll see a little bit here. All of a sudden, this world opens up. Book of Why, Judea Pearl, the whole impact of causal networks and do loops. Spend time in that area. It's really important. And this is where we have a chance, because we're just waiting for that little gray dot in the upper right hand side to turn white again, and we'll get the information. This is a lot of computation. So what does it do for you data scientists out there that have this geeky nature and what CausalNext is all about? It's using things like mutual information theory. There we go. Perfect. We'll cover that later then. Wow, so, that's informative. Look at that.
Right now,
there's the secret of life. Yep. I can understand that.
So currently, it is trying to self-balance the structure. So PyCharts has and other libraries have kind of a tree visualization tool, and it will try to self-balance, like move nodes around to make them not overlay each other, and kind of, so you can at least read through the structure.
Let's move on and make this thing usable now.
Yeah. So right now we just had no thresholding, meaning like we need to a little bit refine our structure. So we'll apply some thresholding to remove any edges that are not as important. So
and this is that now, and by the way, this is a subjective thing, and the idea is removing the clutter till you get to a point where you have some insights, right?
Right. So here we have our structure now, and this is where we're focused on here, the diagnosis. And we can see now that we have, again, we didn't really show the details here, but we have nodes are the boxes, nodes being the features. So, and then we have curves, which are pointing with an arrow, pointing from which one is causal to another. And then we have a thickness of the curves, and that describes the strength of the causal relationship.
And we're going to move on now, but the important thing for this is where you make science. Not everything that we collected is causal to the diagnosis call, but it's all important, right? And that if you hover over the diagnosis, you see here are the things that are important, that are causal to the diagnosis at a certain level. But let's move on, because we want to get the hands on to these folks. So let's move on with this information.
All right, so now that we have this thing here, I'm going to pull out all those features that are causal to the diagnosis. So let's go ahead and do that. I'm just going to pull them out of the graph, and I'm going to apply just those, create a new structure with just the diagnosis and the features that are causal to it. And then I'm going to initialize our Bayesian network. So now I'm talking about the second part. I'm going to apply a Bayesian network onto our structure and compute a conditional probability amongst those. So again, we go back to our feature set, and we've pulled out only the features that are causal to the diagnosis. And then we're going to apply a conditional probability based on that structure. So we've already initialized the Bayesian network. And then, so one more thing is that when we apply the conditional probability, we need to compute from every value amongst every value and other features. So we're talking, if we have a continuous variable, it is going to be horrendously hard to compute. So what we do is we try to discretize those features, meaning we try to bin our features into some range. So maybe from 0 to 0.5, we give it a L1, 0 to or 0.5 to 0.75, we give it L2, and so forth.
Okay.
So we'll go ahead and,
this is a common way I think most of the data scientists understand. So we've discretized the components to make our computation, also to help our learning process as well. So we do that.
And then we go into splitting our data set that we just created here into test and training. So we have multiple rows, 568, and we're going to split them into a training set and a test set. And then we will fit our structure so we'll take the states of each node and apply it for the conditional probability. Then we'll go ahead and fit it. And now that we've fitted it, is that a word? Fitted it?
Fitted it.
All right. And then, so now we can look at the conditional probability of our model.
Which is all super exciting. Let's move into the visualization component. Let's get into Microsoft land here. And that's some really, oh, by the way, here's some really exciting things. We're not going to, anybody that wants to get with us later on, talk about some of this stuff is important. You begin to see things like here, 50-50 kind of numbers that are in here for a lot of the things. It's basically a coin flip. But if you get out here, you'll start to see that radius and texture have an overwhelming set of characteristics on whether or not something is benign or malignant and that sort of stuff. We'll get into that much later on. This is where that information comes. But let's get into the visualization.
All right.
So how we then create a model out of all this that we can use.
Exactly. So again, let's keep this in mind. We have the radius, standard error, an area, standard error, fractional dimension, and so forth. So let's go back into our Azure Machine Learning Studio and create a prediction model. So we'll hop over to the designer here and create a new designer.
And you guys are going to be doing this in the second half of the next study we're doing.
And again, on the compute side, we've already had this already set up with your environment. So this one is your standard one. So let's go ahead and use that one for compute. Now that we've had that set up, so let's go ahead and initially we imported some data sets. We imported the student one, which you will be working with, and then this demo here is the breast cancer one. This one has the whole data set. So the first thing we need to do now is to select the columns we need, or the features. So let's connect this together, edit the column. So again, what we're trying to achieve here is that we're going to select those features that we had already over here.
Yeah, this is where, as Arnie selects all those features, this is where we're turning this into from a standard classifier into a digital surrogate, because these features are causal to those features of concern. We want to be able to change the outcome, just not predict it. So as Arnie selects all these things and puts them in, we're going to get that done. And this is just a brute force, getting them all in there. Text. And as he does that, by the way, it looks like I lost the bet. I lost more people in my session that bailed out than Arnie did. He's only lost one. I need to do something to disrupt that. Oh my goodness gracious. How's that for you? So, and Arnie continues.
All right, so again, we're selecting the features that we want, only those. Now, the next step is to split the data. So we want to make sure we're going to not overfit our data set. So we want to make sure we split it into test and training. Let's apply 0.75. We're not gonna stratify it on now, but we could. So that would mean to make sure we got the same distribution of like our target, for example. So we maintain like we got a same equal amount or equal distribution between the training set and the test set. So now that we've put it in here 0.75, it means that 75% of them will go into this side, and then 25% will go on this side. So this is a really easy and nice way to kind of visualize our process that we are known to do in machine learning. The next step is to train the model. So we put in here our training model cell, and we have to select the column we want to train on. So we're going to do the diagnosis as our target. We go and find a model. So Jerry mentioned we will be using tree. So we'll do a binary or two class boosted decision tree. And we'll connect it here. The boosted decision tree has some parameters here. We'll just use the default. It performs quite well off the bat. The reason to choose a boosted decision tree or decision tree in general is you don't have to worry about scaling or numeric versus categorical variables, for example. So it's an easy way to get started is to kind of pick a decision tree. The next step is that we need to make sure we're going to score our results. So let's go ahead and score it. Move this up a little bit here. So we connect the model on one side, and then I want to test if make sure we're not gonna overfit. Well, we're gonna see if we overfit with our model. Like one part could be that our data set we're just unlucky with our split. The other part is that we're definitely verifying that our model was not overfitted. So that's why I'll bring in and test two sides. I'll test out the training side and also the test side. So again, we'll connect here. We'll take our model in here. So again, this will be trained, and then you connect it to the scoring. So it's going to take the data set, and it's going to take the training, and it's going to score it based on those things. Now, we need to also get some results out. So let's go ahead and use this evaluation model, which is going to be a convenient way for us to compare the two models and give us a visualization. So this is good. Now that we have it all here together, we got the data set, we split, well, we collected only the causal features along with our target. We split the data into test and training. We picked our training models. We specify the target variable. We score each data set, and then we're going to evaluate it. So let's go ahead and submit it. Create a new experiment. Just call it experiment 1. Kick it off. And then we'll let this noodle.
Righty. And this is where this is going to process. But now we're going to, well, that noodle's in the background. Who cares right now? We obviously care. But what we want to do now is get your hands dirty in this space. And like I said, Arnie, you won the bet. I lost a heck of a lot more on my presentation than you lost on yours, which upsets me. I have to seek revenge now.
I just got the stubborn people left.
Yeah, we'll see about that one. All right, so now this is, by the way, I don't want to put anybody on the spot on any of this stuff, but I was going to put a little poll up there. But anyways, okay, enough of that. Enough of the personalized competition with Arnie and my low self-esteem at this particular point. Let's get on to the most important thing, which is you guys. And if I click on the right side of the house, we are actually going to, now this is where you get a chance, if you choose, to move your fingers right across the keyboard. You set up your lab environment, you have your data sets. for those who are interested, we'll send you out the script and stuff like that and run. Some very interesting results come from that classifier. We're not going to worry too much about that now. We're going to get into another data set from UCI. Right? And this UCI data set has to do with a study that was done years ago, published. The data was donated in 2014 around looking to better understand the achievements in secondary education in a couple of different these Portuguese schools. And what they were looking to do was to find out what drove the grades. And if you look at the very bottom down here, you'll see things like absences and G1, G2, G3. So G1, G2, and G3 are what we're going to focus on today, but absences could be another thing you focus on. So what drives grade 1, right? What drives grade in period 1, period 2, period 3? Well, I think all of us can we probably have a pretty good mental model. For all of you, if we were in a room, I'd ask you to raise your hands if you have children in school. You get that. I'd ask all the remaining folks to raise their hand if they've ever been through school. You'd raise your hand. 100% of you out there would have your hands in the air. And why do I bring this up? Because we are all experts to some degree or another in this space, right? So we have an intuition that says something like, you know what? I bet your grades in the second quarter are dependent on grades in the first quarter, and maybe even grades in this third quarter, depending upon grades in the second quarter, right? So we should probably see that somewhere. At the same time, though, there's a lot of other interesting characteristics. Does a student's sex have an impact on grades? If it does, what would that tell us? That should be something that social scientists take a look at. What about the family characteristics, family size? Does a student have to travel farther to get to school or less to get to school? Intuitively, I think some people would say the farther you have to go to school, maybe your grades are impacted. What about whether or not somebody has an activity, wants to learn, right? If you take a look at this, how about this one? Romantic. Has a romantic relationship, right? Does romance have an impact on school? That is a conversation I will not get down on this particular one. Free time, right? All that sort of stuff. So we have some very interesting parameters, of which I think we'd all have our opinions on. But what you're going to do now, with the help of Arnie, is we're going to actually take this data in, we're going to do a causal study, and we're going to pause, and then we're going to create a predictor on grade 1s that we can actually use as school administrators to help us do a better job of driving grades into our school. And if that doesn't make you happy today, then email me and we'll have a conversation on what other things we can do, because this should be like, wow, that's amazing. Why aren't we doing more of this in our respective societies, whether you're from the US or Latin America or Europe? This is what we should be doing. So with that said, let me just make sure. That was my last slide of the day. It is for this particular section. I'm going to turn it back to Arnie, and Arnie's going to walk you through this process. We're going to do a little bit slower, but still at a faster pace. Again, if you don't get to this now, take it offline and do it. You'll have the video, you'll listen to me babble, you'll have Arnie's stuff, and you can do this on your own. But for now, we're going to move back to Arnie.
All right, let me get the
And of course,
content.
you know what I'm going to say next is, I didn't realize that you're throwing your voice. There you go.
All right. So we had a question from Caroline on the why didn't you use 2 execution models in the last box? I'm just wondering if you're referring to the evaluation model. But so the evaluation models, or maybe the question is, why did I use 2 scoring models? But either way, the scoring models will take in 1 training set and so 1 data set and 1 training module, and it will score that data set. So it's just gonna think of it as our data set, the data frame, and you add the scoring to the end. It's gonna add your probability of the first row being benign or malignant. Then we'll do the same thing for the rest of the other data set. The evaluation models
but that other data set is data that the trained model has not seen yet. That's the important piece here, right? So the first set of data was used to train the model, and the second set of data the model's never seen before. So we have an opportunity to see the difference between scoring on each of those with the model applied.
Exactly.
And we'll cover that when we get into the more on the into your actual results.
Right. And then the last point here is the evaluation model is just taking the results from those scoring the data frame on both data set, and it's just going to generate some charts. It's going to generate some confusion matrix. Which
we'll see.
Yeah, we'll see it later. But let's go ahead and jump into your lab. So go ahead and run through the first imports and get all the configurations done here. So this is exactly like we did before, what I showed you. Again, run through here, view the data set. So we're going to look at,
for those who haven't done this before, real quick, because Arnie is magic at the keyboard. What is that? Is that a shift kind of thing?
Shift enter. So highlight cell, shift enter.
Right. And if you see that little gray block, that little white circle by Python 3 in the upper right-hand corner, if you see that white, that means it's done. If you see it gray, that means it's still back there thinking about life.
Exactly. And then, so we ran, and you can see the numbers here is the order of execution. So it shows that we started here, executing here all the way, and then we finished executing up to this point. You see here you can see it hasn't been executed. Again, we're looking at the student performance data set. And again, I'm having issues again with our widgets. So I'm just gonna go and throw it in here. So if you want to look at with the slider here, so you can look at all the fields here. So if you want some more information about the data, you can run this here. I included in the data set text file, and I just throw it in here. Using the exclamation point, we'll go into the terminal on your compute or your laptop, for example. So using the exclamation point, we'll just use so since Azure, we're running things on Linux, we use a cat, which is a common Linux command to kind of display what you see in the file. So here you can see the description for each of the features, and we're going to be focused on the G1, which is going to be the grades for that first semester. So going to looking at removing some sensitive columns. So, Dr. Jerry, we've talked about this before, and if you want to speak more to why we would consider dropping some of these.
How's that for a segue? Yes. So here's the thing. In life, when we're building these models, oftentimes there are protected classes. You know, in the United States, we have constitutional classes, and oftentimes we say we are not interested in whether or not something has a male-female orientation, or religious orientation, or color orientation, or whatever. And that is true. We are in a position where we don't necessarily want to make policy based on that, but we want to know whether or not something we're doing is biased. And this is a natural way of figuring out whether there's either biases in our approach or biases in previous modeling, right? So if you put in male, female, and you find out that more males are likely to achieve an outcome than females, and there's not a social determinant to explain that, it may mean that we have an issue that we got to deal with. So I always argue at this stage of the game to be inclusive in everything. But when it comes to policy making, that is our prescriptive side of the house, our optimization, to be exclusive in those things that we want to protect. But this is the spot that we get a chance to answer or be exposed to new questions. So we're not going to take anything out today. We're just going to move forward and convert those things into the right, transform those categories into the right variables as Arnie moves on.
All right. So again, let's do some pre-processing. So now we've converted all those categorical variables, string variables and stuff. We converted to a number, a numeric, and that's completed here. The next step is to identify the structure. So Dr. Jerry, I wasn't sure if we wanted to get our structure right. I'm gonna remove these columns here.
Yeah. Go ahead and remove them. For the purpose of today, let's remove those columns to simplify our analysis at the end.
Yeah, and also saves on our compute because this is gonna take a while.
Yeah.
So we had in our demo, and we'll send you the demo file as well after this is done. But we were using on this side, we were using the classifier here. On this part here, we're gonna run this using continuous optimization, and it's gonna try to just find the best structure.
Right. So the classifier binary 0, 1. The regression is going to be a linear or a numerical range, right? Which is what grades are, a numerical range. Now, right. You could have gone back and you could have done an analysis by discretizing that into high, medium, and low performers. But why do that when we have two different capabilities available to ourselves? So this is just demonstrating a second approach.
Exactly. While this is noodling, I'm going to switch back to our prediction model here. And I see it's nearly done, so I think this will be done sooner than this will be. So we're just going to stay on the prediction side for a minute and look at some of the results. While this is running, you can also go ahead and you can look at some of the outputs. So right click on here and we can hit visualize. So while we're bringing this up, so this is a good way to look at your data set. So this is our initial data set we had for the breast cancer. We got some the categorical column, the target, the diagnosis. Then it will show us the features. It will show us the distribution on the data.
And by the way, this is so this is the geekiness of a data scientist coming in right now, right? So we can visually see that a lot of these are not normally distributed. We don't even need to go and test that case. And so the question becomes is as we start to build these models, what is the impact of, if you scroll to the right, scroll farther to the right, you'll see, oh, look at that. We have some Poisson kind of distributions in here that are actually causal to in conjunction with normally distributed data. So as a geeky data scientist, those kind of things pop into the brain, right, as we think through here. And again, symmetry mean looks to be normally distributed. So this gives you an opportunity to start thinking in the back of your head, interesting, right? If I were asked somewhere down the road to synthesize data, as a data scientist, I'd want to build models that are equally distributed here, right? And so let's just say somebody said, gee, I want to get beyond the 596 data elements that we have. Could we generate thousands? This is a great place for us to begin to think about what kind of distributions that we're going to have to recreate in order to do that world.
Exactly.
Yeah, fun stuff.
Yeah, and then you can click on each column, and then that will give you some more descriptive statistics. All right. So in addition to this, you can also get the output from the score data set. So I want to give you a glimpse of what we get from here. So again, we selected the diagnosis, radius, all these features here as being the causal features. And then the scoring model is going to just add a scoring label and the probability. And you can kind of start to compare. Yes, we got it right here, got it right here. It assumes all to be correct. And you can also see the probabilities of maybe if you get closer to a 0.5 range, maybe there's some iffy ones that didn't quite know how to classify it. So you can kind of look at the data through here.
How's our other model doing? How's that? Oh, look at that. I won this one. All right. Again, oh, look at that. There's the problem.
Let's go ahead and trim off some of the...
Hey, by the way, this is a great metaphor for life, right? I mean, this is the way our customers view the world. It's highly complex,
right.
It's not understandable because of its complexity, and they give up, we guess. But by just getting to this next step and saying, let's simplify our world now, look at what we're able to find out. Wonderful things like, for example, gee, I guess I am an expert in education because your second term grades are contingent on your first, and your third term grades are contingent on your second. I guess mutual information theory, a field of statistical background, actually applies here. But if we hover on grade 1, G1, look at, out of all the stuff that we got, we have some very interesting causal areas like family supplement. We have things like, and again, I'm squinting here, Arnie, what are those other ones I see here?
Higher. So we got higher education.
Yeah.
We got study time.
Study time. Oh, go figure. Go figure. You know, fifth grader out there saying, I'm done studying. Oh, no. Study time has a big impact on things. What else?
Yeah. Failures.
Yeah.
P status, that's parental
right,
status.
That's important here. So let's just not, whether or not the parents were living together or apart. Now, I know that's a sensitive issue, right? And then the question becomes one of, okay, we're talking to the policymakers here. If now that we know that's causal, what kind of program would you, well, first of all, would you want to put in place programs that affect whether or not people live together or not? But at least they're in a position to know it's causal. And by the way, it's a pretty good, strong causal connection, right? In there, it's a big. And what was the other one here? Family supplement, PSUP.
Right.
So PSUP is whether or not family educational supports, right? Whether or not there's educational support that is provided outside of the normal primary care thing. So we are in. So with this alone, and policymakers can now have a educated conversation about how one can go about improving this. But we're going to use this data now to help them predict and then optimize to the maximum availability exactly what that means by modeling this.
Yep.
So you should be at this spot. Here's a challenge I have for the folks remaining that are holding on, more so that with Arnie than with me. I would encourage you to screenshot this when you do your work. Screenshot this, get an image out of this, and then go on LinkedIn and upload this and say, this is what I learned, right? Here are the things that I see, and start a conversation in your community around this. Well, in two things. One is education. Who's not going to be interested in that in LinkedIn? But the other thing is around the causality piece, and ask your community to talk about this. And you are now doing a couple things. One is you're on your LinkedIn, you're increasing your social presence, but you're also extending this concept to the people in your world, right? And just get it up there and push this around and see what other people think. That's why you'll see that for me. You'll see that taking the stuff that Arnie did on breast cancer and posting some more stuff on there as well, starting the community conversation. And if you do that, please put at Jerry Smith or at Arnie on there so that I see it's happening, and then you connect with me so that I can come in and support your conversation as well in this space. It's a great way for us to extend this conversation and actually change. Here's my promise to you. If you do that, you will begin to change the world through your analysis. Begin to change the world, right? So think about it. Now, don't just be an observer, be a changer. Anyways, let's continue on, Arnie.
Yep. So scrolling back out here, I want to showcase that we have quite a lot of extra nodes that didn't really have a strong causal relationship. So we can remove those by running this command, get the largest subgraph. We'll plot it again, same thing. It's just trying to balance it out, but no extra nodes out there. And so now that we got the structure, let's go ahead and initialize like we did before. Let's go initialize our Bayesian network. We still have our model, we still have our data set to be processed before. We're going to add some, we're going to discretize our data again. So we have some major, we're going to have some major, or the main causal features to G1. So we're going to kind of centralize everything around that piece. So go ahead and and run those, the discretization. So now that we have that discretized, a lot of the other features in here are already in categorical kind of or discretized 1 and 0 and so forth. So we don't have to focus on those. But the G1 is a continuous variable, and it has a range from 0 to 20, I believe. So we will split the grade into pass or fail grades. Let's go ahead and split this into test and training. And then we fit the model again here. And then we can view the outputs. So again, this is quite similar like we had before, where we have applied the conditional probability onto our data set here. But this isn't, let's not dwell too much on this, but this is the second part. And then going forward, we could do some more analysis using the probability that we've already checked relationship, and how if we increase the population on one area, for example, how will that affect our output? So this is really the stepping stone of starting to change the future and seeing the effect on it.
So did we want to jump right into modeling this, or did we want to give them the...
I was going to go and showcase them also one more thing, how we take the final model, the structure, and how we get it into a data set, so have it trimmed down. I will also showcase how to do it from scratch in the modeling piece. So we'll do both ways. But should we, let's go ahead and real quick jump into the model evaluation here. So give people some time to catch up with their own model. So again, this is from the breast cancer data set that we just ran on our causal features. And we connected on the left port our training data set. So the model has seen it, it trained on it, so it should perform well on it. And as you can see, it doesn't even make a mistake at all. Well, it has one mistake. So again, this is overfitted. On the right side is a test set that the model has not seen before, and we can see that it is not as well performing. But we're still getting an accuracy of 93%, which is quite good.
And here's let's go back to the 2x2 real quick. So here, go down, go back to the 2x2. There you go. So here's the thing that we want to think about in the world, which is it's okay, how accurate we are, the 82 and the 50, right? I predicted true and false things correctly, but that's not really the focus that we want to focus on. The real thing is our false positives and our false negatives. And as data scientist leaders, right, with the business community, those numbers have different meaning. In healthcare, if you think about it, if I tell Arnie false positive is, hey, Arnie, you have chronic kidney disease in my prediction, and he doesn't have it, well, you know, at the end of the day, Arnie is upset. He has high anxiety, maybe a little hypertension, but we later on find out through a secondary test he doesn't, he's happy. On the other hand, the false negative is deadly, right? When we say, Arnie, you don't have it, he goes off living life large and normal, and somewhere down the road dies from a condition which we told him he didn't have. That's bad. So in your community, you're going to want to have conversations, because the things that we do to minimize our false positives and our false negatives often are on opposite sides of the fulcrum, right? One thing that when we tip down a false positive, we can often tip up a false negative. So we're going to want to have those conversations with our community in a number of different cases. In financial services, you're looking at minimizing the number of credit card transactions that are thefts, right? And shutting off somebody's credit card inadvertently, false positive, because you thought it was bad, is not a comfortable thing, right? On the other hand, having them go along in a couple months and read their banking statements just to find out that there were $3,000 in unauthorized purchases on their card is also equally bad. And that's one where you may want to balance them out, right? So it's a really interesting area. This is the area that we spend our time, not in how many we get right, but in how many we get wrong, in what categories.
Yep, thank you for that input. One other piece here, if we have some control, like, so normally we always kind of by default go into a thresholding of 0.5 on our probability for the model. But looking at the ROC curve, we can see that it kind of how the curve is kind of more elongated to one side. So this could be a way that we can change our thresholding to modified where we want to be better at.
People are dying.
Do we want to be more right? Do we want to be better at false positive or false negatives? And then so that could be a way for you to kind of control which side you want to be stronger on.
So let's go back over to the education side of the house now. Let's see what that's looking like. We can spend forever in these areas. Let's get through this and then.
Yep. So again, we're going to pull out the features that that are causal to G1. So what we do now is that we just take the features that we wanted that are causal from our structure model. We also add the G1 to the list. Then we take the original feature table that we had here, and we're just gonna bundle it up into one data frame. Now we're gonna save this on our local machine, which is in Azure. So we're gonna just save it as a data. We go ahead and save it. Now it's all saved here. We're gonna use Azure ML core tools. And here's where you need to do some steps here in the configuration. So right now we have a workspace that got set up for us. So we're gonna go ahead and get our workspace name. So Azure ML workspace name, copy that. Gonna replace it here. We're gonna go into our subscription, copy that. And then we're gonna get in our resource group. And that's this one here at the top. All right, and then we run this. It finds our workspace. So now we can take from the workspace, get our default data store. And we're gonna just upload the data we have, college student performance, and register this data set. So it's gonna look up all the files that we have in there and register that data set. So we did it from the command line. We just went in here, we found the data sets, and we just registered this new data set here. So if we take a look at our data here, we can see now that we have only those features that are causal. But the data set that we uploaded initially has everything. So it has a lot more of all the columns in here.
So that gets us into a natural transition into the modeling phase next. But before we do that, I'd like you to go back to the beginning and let's look at that mystery file. For the people listening or following this, they don't have to do this, but I want Arnie to quickly go through the mystery file so that we can get to the bottom and look at the results of the mystery file. Because we're going to ask the question. Somebody gives us some data and we're going to come back and they're going to go, can you tell me what's causal? So let's just go through this. They give us a mystery file because they know we're super smart. Again, fiery hoop of death, right? Somebody comes and says, you're so smart. Tell me about this file. So Arnie uploads it. He brings the data in. And we're going, oh, look at this. No even variable names on here. Oh my goodness. But I do have a target.
Yep.
That's interesting. Okay.
Classification target. We got 30 features.
Keep going down. Let's just process this and let's get to our diagram as quickly as we can.
All right.
There is a life lesson in this one. Fiery hoop of death. Person who challenged us in this space. We're processing just like you did before, right? Lo and behold, it's cranking away there. It's the gray blob hasn't turned white yet. So Fiery Hoop of Death person is kind of grinning on the sideline going, yeah, I'm going to show this Ernie guy. I'm going to really check to see what is his metal made of? Is it lead that I can penetrate, or is it chrome? Is it steel? Is he a answer lot on this one?
I'm going to jump over here while we're give it a minute. I'm going to bring in the student data performance and our student one.
All right.
But I'll peek over here. Oh, look at that! Right. Look at that!
Oh, look at this! All right, we got our matrix of confusion here, our network of confusion. It looks a little different, but it's trying to normalize itself. Okay, now I've recognized that mess. Let's do a little filtering here.
Yeah. So you can see it's not finding anything in here. So let's go trim this out. Well, it doesn't even find anything. Well, let's relax on the trimming.
Tighten it up a little bit. Tighten it up even more. Go back and trim it up even more. Let's just see if we can get.
.3 maybe. Ah.
There we go. Now make it a 4. Higher level.
Yep.
Higher level. And there's a purpose in this little thing here. All right. 3.5. We'll, later on, for those who are interested why that's happening, we can talk about that offline. But
3.2 maybe.
We're trying to get to the spot where there's actually something there that can generate it, but is the highest level we can look at. Because and if not, the
might be 3. It might be our
let's just do the 3.
Closest we can get for the time being, at least.
Yeah. So let's just take a look at this. So what is this saying to us? Fundamentally, this is saying that really nothing's connected to anything here, right? You got some strong calls, and that is indeed what this file is. This file has a bunch of columns that are generated random numbers by the random number generator that Microsoft provides, right, through their operating system. And the outcome is, again, another random number. So what we see here is fundamentally unconnected stuff. Now, here's the interesting thing that one finds out. If you go back, so that's what this is teaching us, that random is random. And many times there are no relationships. But just because we don't see something at the level we have doesn't mean that there's not a connection. So let's make this back to point 2. Right? Make this back to point 2. And then, so here's the interesting thing. This is truly, these data is random. There's no codependencies. But what is this telling us? That even as we dig deeper, as we go from the system to the subsystem point of view, the subsystem point of view into incrementally deeper levels, as we really trying to draw on any causal kind of characteristic, it turns out that there are relationships between these random variables. And those relationships have to do with the way random is generated in systems. I think as data scientists, we all know that random is not really random in a random number generator isn't really random in life. And that this is one of the things that we can use to see how random our random numbers are, or how independent our random number generation is. And this just shows that looking at the entropy between those numbers, that there is a relationship. Right. So as a person who's involved with simulations, and we're trying to create 2 different ecosystems that are truly random from each other, we have to analyze our data. And this is a great way to do it from a causal model perspective, is to say, listen, is that random system over there that is supposed to be truly independent from this random system over here truly? Well, you can do this analysis and you can show yourself exactly, right, if there's a relationship between there. It's just a fun little thing. Again, grabbing data in the world, doing a causal analysis of it. At my house, I'm my wife's data scientist. She's in real estate. She's always giving me data sets and going, is there any relationship to a sale and this stuff? Well, guess what? That's what you can now do. You have that power that's in there. So let's move over now to back to our modeling, and let's continue on with the Microsoft stuff. So a little lesson on that one.
All right. Yeah, thank you, Dr. Jerry. So now we have this data set, which has been trimmed with only the causal features. And then this one is the data set that has everything in there. So I brought them in both here, just to give you a small exercise on how you can build the model. So since we have all the causal features, there was one extra feature though there. I forgot to change the code at the bottom here. When we export as a CSV, I could have removed the index in there. But anyway, so it is what it is. So let's go ahead and select the data we need. So this is just for demonstration. I'm going to run them in parallel, so we can take a go through the exercise. So we're gonna pick the column we need here. So actually, let me just start on this one here. It's easier to get us going. So actually, this one is already, it didn't have that index, which I thought it was. So since this one was already prepared, I can just go ahead and split the data on this one. Bring in our model. Get our 2-class boosted decision tree. You can pick whatever model you want. And then let's score the model. So again, let's bring in 2. Always good to check both sides. Check our results for the data set we haven't seen, and then we evaluate the model. And then I'm just going to remove this one so we don't get any error. We got to select our target, G1, and we can run it. Experiment 2, and we'll submit it. So while this is noodling, I can continue to build out this one for demonstration purpose. And I can also show you how to, if you wanted to build a model a completely autonomous way. But we'll do that if we have time.
Yeah, we have a couple of the subjects to cover here, and let's go back to the model that we're running here and talk a little bit about where we are now. So if you think about our process, we've talked to our customer, which is the educational group that's asked us to help them figure out if there's a better way to improve the grade results of our students. We've done a field study. We've collected a lot of data between various schools, and we brought it in. Our data scientist has brought that data in. It's aggregated together, created a uniform machine learning record. And what that is, it's a horizontal row that has columnar data, right? So columnar data being the variables. and with a target, and that is our grades 1, 2, and 3 in this particular case. And so that's the initial work that we've done. And why did we do that? Well, let's go back to our process. We know that data is the debris of activity, human activity, and we've gathered as much of that human activity we can that's been persisted in the data we have. Let's talk about what happens when we actually don't have, we did the results, right? We don't have a causal tree. There's really nothing there. Do we stop? Well, the answer is no, we don't stop. That just means that we have to go find new data, right? And that gives us an opportunity to have our group actually give us a reason to bring in other, determine other data elements, social determinants of education or health or whatever. So going external with that. We brought that data in, we did the causality work, and lo and behold, we found some very interesting pieces. And remember, all those pieces are, if you change that value, you change the grade. If you change that value, you change the grade. So the question then becomes is, under what conditions will changing that value result in a better grade? So Arnie is doing, Arnie, you have sat down, you've gone into Microsoft, you visually pulled together a model. You can see it's pretty straightforward, right? Even for a data scientist like myself. And don't underestimate the value of picking the right model. It's not a random routine here, right? And by the way, we didn't do anything with deep neural networks yet. Nothing is in that space. There's other ways that we can do spatial and time series based behaviors. That's a whole different conversation. But now we've built this model that we can use with our policymakers, because our policymakers are going to go, okay, I get it, family support, all that stuff is important, but they're going to ask the question, if based upon what we have now, what do you predict, right? If we increase family support by 3 units of family support, or if we come back here and do family size, or if we come back here and do things like family composition, if we can help people stay together more as a family, what is it going to, how is it going to impact the result? And you'll be in a position to actually have that conversation, right? And in this space, I think, Arnie, in this space, what I'm going to do is I'm going to take back control, and we'll move into the last section here real quick, if you don't mind.
Yep.
And then
no, go ahead. I just wanted to say one more thing, that in the part B notebook that I sent you, it was showing us a process of taking our student data set from the very beginning, where you have to bin your G1 parameter and so forth. But what I've changed now also is that we exported the student performance data set already ready to go. So our path was a lot shorter than what the image shows in the notebook, just to clarify that one. Yep.
A couple different pathways to all this, right?
Right.
Just pop over here and do this, and then let me, oops, not that, stop sharing that. Share the other screen, which is this guy right here. There we go. All righty, and then turn this thing into a live stream for you guys. There you go. There we go. It's like a multi-step process sometimes. And I'm back live. All right. So now we're at that process, right? We're now at a step where we know what's causal. We can predict over space, right? Over characteristics, not time. We didn't talk about time yet at all, but over space, how things will change. And now our policymakers are saying, you know what, Caroline, you know what, Arnie, Joe, you guys are awesome. What gets the best grades, right? And that's what we're not going to do this work today, but we're going to talk about it. And that's that last stage of the process. And let me just get through here. That's the optimization discussion process. And this is one of, so data engineering on a scale of 1 to 10 in terms of our ability to do it as a community effectively, repeatedly, is a 9.9, right? We can data engineer anything. Causality, as you can see, is, I'd say we're on the scale of 60, 70%, really figuring out the causal models. Again, go back to Judea Pearl, the Book of Why, study that space. There are other tools out there that we can use. Besides this, we have Compellon, we have CausalNext, we have, and if you have the money and you really want to dig into this space, Bayesian Labs, which I just love to death, but a little on the pricey side, but it does so much more. So that's like a 6 or 7, right? And then you get into the predictive modeling. Oh my goodness gracious, there are more things that we can do there. So I'd score that an 8 or a 9. Prescription, the optimized work that we're going to talk about now is about a 50-50 call. It's the area that as a community we have to work on next. And why? So now we have the digital surrogate model, right? We have on the left-hand side of our digital surrogate, we have all of our causal factors coming in, and then the correlation factors we've cut off. And by the way, don't underestimate the power of a good correlation, right? I use the analogy, it's a lot like surfing, right? A good surfer doesn't create the waves, but you give them a board and the ability to read the waves, and they can do some real magic out there, right? They don't create those waves, but they can really write a causal or a correlation all the way to the shore and do some amazing things in tubes with those correlations. So if you don't need to change the world, you just want to take advantage of it, correlations could be something you add to your arsenal. But if our goal is to change the world, if that surfer wanted to do a better job, he'd actually create the waves when he wanted the waves at the height and the right kind of velocity that he'd have to maximize his performance, right? And that's what we're doing here with that causal input. And then, of course, the output are your predictions, right? What are the things that you want to do? And here's the neat thing, which I didn't really emphasize in the beginning, but it's good now. I noted 3 there. This is a multivariate output, right? So a lot of times when you and I are asked to help maximize something, we think in terms of single variables. We try to optimize a single variable, a time, a cost, a quality issue, but they're all interconnected, right? So being able to do multivariate optimization is an important piece. We see it in neural networks today with gradient descent and stuff like that. But this is the world that we're working in now. So how do we do this? How do we solve this? Well, one of the simplest approaches we can do is actually Arnie and I can sit down, you and I can sit down, and we can just vary the inputs of each of those causal dimensions over its range and look at the output it has, right? But that has its limitations, right? If you think about a causal model, a digital surrogate, it has 3 inputs and 1 output, and each of those inputs are binary in nature, has a yes or no kind of input. That's 2 to the n, 2 to the 3 minus 1. There's 7 different combinations of taking A, B, and C and combining them together and looking on the output. If we take 10 inputs, that's 2 to the 10 minus 1. That's a lot of computation, right? That's a lot of us going through that table. That design of optimization experiments is really hard. So what do? We move into real quickly into, like stochastic methods, like Monte Carlo. It's a great application, right? We know the inputs. We know how we already talked about it before. We saw how they're distributed in the beginning. And we can then run those simulations on the input, and we can say under what of those conditions maximize my output. And that's a very, very, very popular method, right? We can do constraint-based optimization, linear multi-objective constraint-based optimization in that particular case. One of my favorite, though, in this case is 2 areas. One is particle swarm optimization, which is a very important area here, right? PSO, right? You can actually take this multidimensional world and surf through the entire solution space, like in the graph here, and find out what areas. And the one that will most impact all of us, it's not quite there yet. Is in the area of what we call population-based methods. And for guys like me, people like me, I should say, that's the world of evolutionary computing. Right, evolutionary computing. That's the world of genetics and Holland and stuff like that, right? Being able to take and encode information into a string of basically synthetic DNA and then varying those and mutating and all that wonderful world. If you're interested in that, put into the comment area that you'd like to see a section on that, and we'll talk a lot about it. Why is that important? Because evolutionary computing is a functional quantum computer. And this is, as we start to maximize the number of inputs we have on our prescriptive optimization models, we go from 3 to 10 to 100, right? That sort of quantum impact. Your dimensionality becomes very, very complex, and we lose control very, very quickly of checking each of those spaces. So by using evolutionary computing, a functional quantum computer, we take advantage of the world of digital entanglement, which is a whole separate thing, but we actually have the ability to hold all possible state spaces in one area and identify the maximal a possible condition of multivariates on the output. And if you're interested in like Sahid, I'm going to publish it. Arnie's not paying attention anymore. We've got a couple folks interested in this. We'll get that out there. It's a new world, and again, this is those areas, right? So we can walk out today and we can use Monte Carlo. Well, we can do it by brute force if you've got a couple dimensions. We can use Monte Carlo, a little bit of time, part of a swarm optimization. Those, you attach those to your data science belt, and we can actually optimize this stuff. And as a result of that, we can go back to our policymakers and say, here, in order to maximize G1 grades of our students, these are the conditions in which you want to have. And now who do they turn to? Well, they don't turn to sales and marketing, right? And say, okay, how do we do this? They turn to their psychologists and sociologists, right? Their psychologists are going to say, here's how we can work with individual students to get them to perform better in that particular variable. And here's, from a sociological standpoint, how we work with communities, whether it's family members, et cetera. And now what have you done? You're now at stage 5, right, of the process. And what is stage 5? Go out into the world and put your ideas to work, right? And watch what happens. People apply them, people change, and what do we get? We get new data. Start at step 1, collect that data, causal, walk through, wash, rinse, repeat. And the world changes. And the world changed because of you, right? Your world changed because of your ability to help people, communicate it in a way, work with the policymakers, in this case, communities, in other cases, it could be healthcare providers and payers. In other cases, it could be banking officials. In other cases, you could be working at a large retail chain that is looking to reduce the spoilage that happens on their shelves as part of a major global initiative. And they're asking the question, what causes spoilage? And can I create a digital surrogate for spoilage, bananas? And then how do I minimize the amount of spoilage that occurs across a very, very complex chain of harvesting and transportation and storage and product merchandising and store sales? That is a complex set of multivariates that no one person can possibly do in their brain. You have the key now, to help them through that process in that space, right? We won't get into the optimization piece, but I will take the advice of some of the folks that have been saying yes, and we'll work through that space out of there. Arnie, did you get results? Okay.
They're still
cranking away. That's a big one. It's a big model. So we are at the spot now where I'd ask anybody hanging on with us to think about questions, right, as we go through this sort of process. Let me just go over here real quick. I'm gonna do some wrap up as you guys come up with, if there's any questions. If you don't have questions, I'll make them up. I think you guys can figure out right now, I do not have a problem with talking. Sometimes I have more than a problem, but let's just talk about some next steps. Finding data sets to work on a problem. Yes. All right. So, boy, I wish, I'm not really good at pronouncing names, but we have one question out there. How do we find data sets? So my favorite spot is UCI. I would go there. So one is invoke your research team, Google. Google is awesome. The Google research group out there, just type into Google around data science data sets, and you're going to get a whole list. I find UCI as an awesome source of data. I have not yet found a problem where I couldn't find a data set in UCI that didn't parallel the knowledge that I needed to get to solve the problem at hand, right? So breast cancer data could be used as the framework for which you can begin to solve spoilage, right? Because it's similar characteristics and attributes. So the good news is that you can go into UCI and just study those data sets, thousands. I think now over 1,200 data sets or something. I forget what the current number is. I look every week. I start my week off with just a half an hour cursory review of that, and I look for the new data sets. And then I just randomly go through and pick up an old data set that I haven't seen before, and I find Shide.
That's how I pronounce it.
Shide. Thank you for helping an idiot like me pronounce a name that seems so easy to pronounce. I appreciate that. I truly do. So I go in and I just study one, and I always ask the question, what problem could I have used this on? And what problems do I think I could use it on in the future? And I forced myself to have that mental conversation. And I actually didn't say it out loud because of that natural linguistic processing, what we call psycholinguistic analysis, that allows your brain to hear it, codify it, put it in your prefrontal cortex, store it in your background. It's a very important thing. Do not underestimate, and this is just cognitive psychology, Jerry coming out, the power of talking to yourself in this space, right? We know that when you're in a meeting and you have conversations, the best things come out at the end. It's because our brains are tuned into that. Having that conversation with yourself is equally important. All right. So that's it. And then what I'll do is I'll put together a list. Arnie and I, we have lists ourselves that I track. I have keep track of different lists, and if something doesn't fall out on that one, then I move to one of my other lists. Right. There's a lot of government stuff. What about you?
And another one is Kaggle.
Kaggle, yeah, awesome, right? Awesome spot as well, right? To pull out data sets that are out there that are relevant. And by the way, some of the problems, that's a really good place to figure out what's on people's minds, right? In terms of problem solving. All right, so thank you very much for that one. That's a good one. Matter of fact, that may be an interesting conversation in itself. So where do we go from here? So a thing is, I'd love to get some feedback from each of you, right? This is the second time Arnie and I have done the Dr. Jerry and Arnie show. I think we're getting better at it. I lost the bet. He lost less people than I did, which tells me something, I guess. How do we get better at this, right? In this particular space, do we need to spend, less time on the PowerPoint stuff? Oh, here's an area that we always debate, which is if you've gone through any online training, you'll notice that they leave out stuff and they have you struggle with it for a while. And then after 5 or 10 minutes of struggling with it, they then come back with the answer and you move forward. Is that useful? I'm not sure. But if you have ideas on how we can improve, please send those back to us. Just send us we'll show you a link here at the end. Just send us those ideas. That feedback is really important. We also have feed forward stuff, right? We would like to hear from you about how you think you're doing this. Now, I'm going to tell you this now. This is not a sales call. I'm giving you a chance to write me, jerry.smith@agilethought.com. This will not go to sales. You write me and say, Dr. Jerry, I'd love to talk to you about my area that I work in, my business problems that I work in. We'll spend 30 minutes, 45 minutes, just brainstorming the shit out of this stuff, right? You and I, maybe Arnie too, right? And the three of us will get together and we'll just have a session. You walk out with it. If it does you any good, great. If you want some additional stuff, if you turn to me and say, I like this, I give you permission to sick your salespeople on me. We'll let our wonderful salespeople help you through a process that I think we can help you with. But my point on this one is, if you think there's value in this, if you see the opportunity to change your world through this process, and you just want some mentorship, some clarity, write me. I'll get on the call with you, and we'll just spend a little bit of time, right? Whether you're at a Home Depot or a Lowe's, or whether you're at St. Jude's, or whether you're at American Express, we can do some real damage with these ideas and really make an impact. But the very first thing that has to happen is you have to get off your X and step forward. I'm not saying you have to do that alone, and we are here to help. And I will keep our salespeople away from you until you tell me it is okay, if at all. So we'd like to hear from you. The other thing is we do have some upcoming events, right? How relevant is your graph theory to graph? Oh God, that's the first one. Who did that? Was that anonymous? Pat asked the question, how relevant is your graph theory how relevant to you is graph theory and graph database? Well, you're going to get me really excited here. First of all, graph theory, very relevant, right? So, for those who are thinking about this, think about when we do social network analysis, right? We're looking at things like betweenness factors and other clusters. How do we know what parts of a community that is represented in a graph are important? So there's a whole field of science around graph theory. So let me just, different conversation, but let me just tell you, as a data scientist, there are three things that we bring to the table. We bring our frequentist personality, that is clustering, classification, time series analysis, right? That's the frequentist point of view. The other is the world that comes from our inferencing point of view. This is the statistics. This is the one and only joke that I have. This is the world where 5 out of 4 people have problems with statistics, right? If you just let that bake in, usually the audience laughs, and the person who doesn't laugh usually laughs within a minute or so. But this is the world of statistics, and we spent a little bit of time in there. But the third area, which is so undervalued and is so powerful, is the world of graphs and graph theories, right? And if you're ever interested in understanding a really interesting business problem, and that had to do with the Panama Papers, right? A report back in the day, what was it, 10 years ago or so, 20 years ago, can't remember anymore. A young reporter got access to a bunch of data elements, databases of people that were offshoring their wealth in foreign areas that had no reciprocity with the United States. And in this process, she got this database, and she sat down with 2 young data scientists who worked with Neo4j, and which is a type of graph database, right? And they took this data, they natural language processed it, they created its atomic elements, and they stuck it in there in this graph database, right? And using Cypher, which is the language of love for Neo4j, they asked questions like, show me all the people that have accounts in the United States that weren't paying taxes offshore that we can go after and harass and you know, blow the minds out. You know, some natural language process, and they found lists of people that were amazing, right? And here's the whole point in this, is graph theory is used by about 5% of all data science projects out there, machine learning and AI. And it actually can exponentially increase. I use that word a lot, but it's one of those areas that if you put an additional 10% on that, you'll get 110% out, right? And if you're in banking and finance, I'll give, for all those that are in banking and financial services, for all those that are working in anti-money laundering, machine learning, and that sort of AML areas, here is your project that will get you promoted next year. You go grab every SWIFT record and ACH record. SWIFT records are what? That's the transactions that I do to you overseas. ACH records are the transition I do with you here in the United States. So they have the amount, when it was, a bunch of attributes. You take those records and you dump it into a database like Neo4j. And after that, you look at the results. Now, here's what I want you to do then. Now that you have a graphical database of people connected to people through money transactions, I want you to go look at your next person that wants to do something and compare that with one of your blacklists and ask the question, how far removed are they from that person? Here's what we found out when we did the 9/11 analysis. We found out that more banks were allowing people that had 3 degrees of freedom or less between the person that wanted to open up an account with them and Osama bin Laden. So if you've got somebody who's 1 degree, who is 1 degree away from that, you think that person may be a bad guy? Absolutely. This question about graph, absolutely super important. You cannot, you can't do causality without it, but you can, with it, you can do so much more. So thank you very much. I mean, Pat, that was really super important point to that.
We got a few more questions, Jerry. So
where are they?
Shide said he would love to move the session later in the day so that people on the Pacific side would be able to attend. So I suggested, yeah, maybe we can move it for our next session on March 16th. To be
or we can be all under the same pane. We can have it at 3 in the morning, right? So everybody is under the same pane. But it's a good point. And then it looks like Caroline would like to see more. Oh,
yeah, that's a good one.
So you get me excited about some of these things, right? So AI, the world of AI ethics, artificial intelligence ethics, and responsible AI we should do that. Yeah, that is. Okay, we're going to do that. I'll make sure that we get that out there. That's more of a 45-minute one, traditional one. We can talk about that. There's some great stories. Okay, we'll hold off on that one. You're right. We'll get that going. We'll make that happen in the next few months. All right. So, lastly, in this space, thank you very much. Two great suggestions. By the way, Moving it earlier in the day or later in the day so people can do it, that's a great suggestion as well. But in terms of content, I like both of those. All right. Some upcoming events. When you press your key and nothing happens, that should tell you something. Here's some upcoming events. We do have another AI day coming up in March, so we're going to make some big changes in there, new data sets and stuff like that. Our goal is always to. Our goal in doing this is not just to repeat it because we can just play the video over again, right? In that, our goal is to make news, make some new science, right? You will see us in the next one using one of our partners, which has access to explanation of benefit information, massive amounts. You will see some news come out of that one. So just keep in mind, ooh, nice little AgileThought double print down here. You will see some, when you see that coming, I would encourage you to hop on that, if nothing more, than to see, we're using UCI data, right? We're going to be using one of the largest data sets on planet Earth when it comes to healthcare data sets. And we're going to be crawling through that space and doing some interesting, that's going to come in March, right? We also have some analytics in today. I do own analytics. And so we're going to be doing similar things when it comes to engineering and how do we create BI-based dashboards. And for you folks that work a lot with your analytics team, what's the most important dashboard that your analytics team can create that they're not doing today? Well, if you've been focused on our conversation, it's a causality dashboard, right? And there are two things that we can do there. First of all, we can bring up a dashboard that says of all the data we have, by the way, we listen to our CEO and our CFO and our CMO and our CIEIO out there tell us that this is the important things for our company, right? X, Y, and Z. We sat down and we took all of our data and we looked at X, Y, Z and we said, what's causal to X, Y, Z? What's causal to our revenue? What's causal to our sales? What's causal to us losing customers, right? We looked at that and we found that this data is causal. Guess what dashboard you're going to create? A causal dashboard on data so that the company can look at it and say, if I can put $1 more into data, do I put it into data that isn't causal to my business concerns or put it into data that is causal to my business? Of course, you're going to put it into ones. You're going to enhance that, curate it, spend more time, create more projects, ask the question, you know what? Look at this data over here. We have no internal projects on that data. Should we? Duh. You don't need to be a PhD data scientist to figure that one out, right? You will make you will get a promotion on that one. Right? The second one is showing the graph, right? So a dashboard that not only shows this is the data that's of interest, that's of value to us, but here are 2 or 3 graphs, right? 2 or 3 targets. And let the business people look at that and go, wow, Steve, Marianne, come on over here. What are we doing in this area? Who controls this in your group? That opens the door to brand new stuff. So you will learn about some of that in the analytics and the day side, right? And that's the step that they have into data scientists, and that's the step that we data scientists have out of their area that joins us together. That'll be awesome. Okay, so look forward to those things.
Yeah, we had one more question from Gustavo.
Go ahead.
So data quality is a common issue. Could you have some tasks added to examples? And I think that we will probably add that to our next session in March. So we'll try to do a little bit different causality, try to add some more prescriptive stuff to the causality for March 16th session. And then we'll add a pipeline to kind of do the data quality process. And
with that said, though, let me flip it around. And let me just, this isn't provocative, but let me say this. I don't care that your data isn't of quality. And you'd say, oh, really? And I would say, well, the very first thing I would say is, do we have the right data for our business? And we call this data IQ, by the way. It's a measure, right? And so if we take a look at all your data and it turns out none of your data is causal to a business concern, does it matter if all the data is high quality? If you have on a scale of 0 to 100, let's just call that the IQ scale, the data IQ scale. And let's say that less than 30% of your data is really relevant to your business. Should we double down and put more money into making it high quality? That is filling in the missing fields and values and making sure that's all consistent? Maybe. I would argue you better go find more data that's relevant to your business, right? And right now, businesses don't think that way. You can help your CIO become a superstar by saying, boss, we looked at all of our data. We took all of our data through this process. We took a look at our top 5 business concerns over the next years. Hate to say this, less than 5% strategic. We need to change. We're recommending the following things, right? Go out and bring in FactSet, other data sources, et cetera. You will make him a champion. On the other hand, let's just say that you've got a large wealth of data available. 95% of your data out there is really driving your business. Now you know you need to curate the crap out of that, right? You need to really work in that space. It's in that gray zone that we start to think about things. Do we have the right systems, right? You're between 30 and 70%, right? Do we have the right systems? Can we create another pathway? We've all heard this. What are our customer journeys, right? Well, I know a lot of people on the technology side hear blah, blah, blah when they hear that. But the most important digital transformation activity you can do is measuring the intelligence of your data so that you can quantitatively identify your missing journey paths with your customers. Go back to the original statement. Data, repeat after me, data is the debris of human activities. It's because of us, not in spite of us. So if you can quantify that data, you can empower your transformation team to say, here are the pathways that we need, right? And here's the way we create an application. Here's the way it interacts with people. Because if we do that with the simulated data, look at how we now change the world as a function of our company. And that's the simulation stuff we haven't talked about yet, right? That's the whole simulation field and how do you deal with synthetic data as part of the transformation. If you're interested in using synthetic data and simulations as a pathway for digital transformation, let me know, right? Let us know. Love to talk to you about it. That's how you apply this world with some other worlds. You take 2 different sets of capabilities, squeeze them together, and quantitatively enable your company to really achieve the goals that they want to. Cool stuff. Okay, last thing here, accelerate. I'm really excited about this, not because it's a AgileThought conference, it is, but because we are putting on a conference February 25th, where a bunch of leaders outside of our company, some inside of our company, are coming to speak on some great conversations. There are people coming to this conference that I've always wanted to talk to and I've always wanted to listen to. So on this list are those people, some super creative people, some people that are innovators in this world, some folks that have access to some causal social determinants of health, wonderful conversations we're going to have across the board. I'd encourage you to register for this, if nothing more than to put it on in the background, listen to some of these areas and ask yourself, how can these things help me? And you're going to get excited by hearing these folks, right? This isn't your standard mom and dad conference where people are up there pitching products. We don't pitch products. I think you saw that today. This is the only time I'm telling you about our stuff. We are pitching ideas. I want to be that grain of sand in your brain that turns into some sort of set of pearls over the amount of time, right? And I want you to come back to me and say, you know something, it's been 3 years, but I remember when you said that, I didn't think much of it. But I started to do X, Y, and Z. I did a little bit more work on causal and X. I applied these sort of things. I talked to my business people. We talked about using synthetic data to do this stuff. And by the way, I saved a child from dying. I saved a person from losing their valuables. I helped a person gain more knowledge. I just wanted to thank you for that. That's where I get paid. And I think you guys are on that path now. So you're going to hear from people that are on that path in this section. And I encourage you to let that be the energy of your life, the fuel that you use to take what knowledge you had today and turn it into the activities that will change your world. In my little closing piece, I showed you my crystal ball over there. And the second crystal ball that I have is this one. And this is a crystal ball that has something in it. Because most crystal balls you look into and there's nothing there. But this reminds me that I can change a world. I can look into this sort of thing and see a new world, a new landscape. And now that you are empowered with that ability, you should feel very bad. What I mean by that is, you should probably find yourself staying up later and later at night, right? I'll tell you a little sidebar secret of me, and I'll come back on that comment. I was in the intelligence world for a long time. If you look online for Dr. Jerry Smith, DreamWorks, Dreamforce, Salesforce, and data science, you'll find a presentation I gave back in the day when we used data science to hunt down traffickers of children in the sex industry. And we used the same process. The process you saw today, we used it to find people who bought and sold children. Why is that important? Because once you are empowered with a minor superpower like telling the future and changing it, you find yourself staying up later and later and later at night, not willing to go to sleep, because you can save one child, two child, a handful, so you can get that kid off the street in 72 hours back to their parents, right? And eventually, you see the payoffs. And I hope, my prayer is that when you look at this process that we walked through today, you sit there and say, you know what, I can do that not only for my company, but I can do that for something else that's important to you, right? That's important to you. And that you lose sleep over that. And that you actually curse Arnie and I in the middle of the night and say, thank you very much for not allowing me to go to sleep. And I hope you write me and say, how do you now sleep at night? And I'll tell you my secret on that one as well. So once you get to that spot where your significant other says, go to bed, you have to sleep, you write me and we'll talk about that next phase of your life. But that's where you are. You are now empowered. Arnie, do you have any last things before we say goodbye?
No, I think this was a great session. If you wanted the model, I could show that as a.
Well, why don't we leave that as an exercise for them, right? To go off and do that particular piece. And if anybody has any questions on that, again, we are offering. Go back to this little guy here. Don't lose sight of this, right? Email us, right? jerry.smith@AgileThought.com. You write me. You can either say I'm an idiot, or you can say, hey, I'd love to take you up and let's chat about this stuff and add that to your list. Right? If you just want to go through some of this stuff, we'll spend a few moments with you. You spent the time with us today. My commitment is to spend time with you tomorrow so that we can change the world, right? Change the world. Do not let this event not change your life. If you do, that's sad. That's sad, right? So, and that's more than just doing this stuff, right? I think you know what I mean. Anyways, thank you very much. We really appreciate you hanging in. Arnie wins. He lost less people than I do. I got to figure out what I'm doing wrong in life. Other than that, I appreciate it. Go off and use this stuff. Go off and change the world. Connect with us on this, and we look forward to seeing you on a next event with us. Bye-bye all.